thumbs up on the cameras. We can see everyone. Hi, everyone. Welcome to the AWS Activate workshop with Mission. It's going to be an event-filled day, lots of education. Today, I just want to kick off and say that it is all about you, the customer, your questions, your engagement, your needs. It's an immersion day designed for you. So hopefully we can have an active and ongoing communication with the chat. If you want to, we'll do some introductions and kind of kick off with the agenda.
Hey, that's me.
Pull up to the next slide. Yep, that's me. I'm John Macchia. I've been at AWS for 4 years in the partner development space. I've been in the tech space for 17 years, 21 if you include some in school. You can read it all on the slide here, but I spend the vast majority of my personal time with my family and my kids. So two under the age of 3. But I would say in my spare time, I am all about technology and I'm all about AWS. So it's kind of my ongoing joke. So one of my favorite quotes I always put up there is proper expectations and trust determine the difference between success and failure. I think it's a very, very important quote that resonates with me daily because the proper expectations that we're looking are we expect our customers to ask us questions and ask us hard questions, and we expect ourselves to be able to dig in and dig deep and answer those questions and help find solutions and help find answers to any questions that you have. So we definitely want to make sure again that we're engaged and we're engaged in conversation today, and you're asking and anything that pops up. But that's me, John.
Thanks, John. So my name's Scott Goldberg. I am the manager of the Solutions Architect team here at Mission. I've been working on AWS specifically probably for almost like 9 years now, but before it was cool, before all the kids were doing it. So lots of experience building workloads, migrating folks to the cloud. I've had like a number of positions at Mission here over the last number of years. Used to be kind of in the delivery side of the house and on our DevOps team, and then more recently on kind of pre-sales solutions architecture. So a lot of experience working with AWS on funding and all kinds of things like that throughout my time here. And so I'm a major smart home and 3D printing enthusiast. So if anybody needs some tips or tricks or wants to chat about that at some time, I'll always nerd out on stuff like that. And then, like I said, you could tell I kind of have a troubleshooting background because my best quote is, "Have you tried turning it off and on again?" It's a little different in the cloud, but you'll find that it usually fixes a lot of things that you might be running into. So. And then we've got a number of folks from the various teams here, so I think I'll kick it over to Lance.
Howdy, folks. So like Scott, I'm also on the solutions architecture team, pre-sales roles, and also like Scott, I've been doing many things here at Mission, us being a consulting partner. So been on the platform team, building internal tools, CI/CD pipelines and workflows, consulting team, working with customers and providing consulting and advisory services, been on ops teams, maintaining workloads, production infrastructure, root cause analysis. Before I even got into this cloud stuff, I was doing IT, systems administration, and help desk type stuff. Right. So that's kind of me, and my experience has been rolled up here today, being on the pre-sales team. Over to you, Brian.
Hey everybody, my name is Brian Riesgraf, Solutions Architect here with Mission. Prior to Mission, I actually did a stint at AWS as a Solutions Architect as well. So I'm kind of on my own personal cloud journey that I've been going on for about the last 3 years. Before my cloud experience and kind of jumping into AWS, I actually did really I did infrastructure build for a big health insurance company that did everything on-prem in AB data center world. So I come from a really big data center background, and now I'm kind of on my own personal, cloud discovery path. So I'm up here in the Great White North of Minnesota.
Cool. Ari.
Hey, good morning, everyone. This is Ari Mukherjee. I'm a solutions architect with AWS based out of Chicago. And I support all our AWS customers in Midwest, primarily Illinois and Wisconsin, working closely with our consulting partners like Mission and many more.
Thanks.
So the agenda for today, I'll let everyone just read really quickly rather than go through it line by line. So we can kind of move through this relatively quickly, unless someone from the mission team wants to jump in and touch on any of these very high level.
No, I think it's pretty straightforward. We've got a number of cool labs and presentations for you all throughout the day. So you'll hear from all the different folks that just introduced themselves, and we'll have a couple breaks in between. And you can always hit anybody up here in the chat if you have questions or comments or concerns as we're going along. So I guess I just wanted to start with a brief kind of intro about Mission and who we are. So we're a premier consulting partner for Amazon Web Services and also a managed services provider. So we provide a range of services and we're 100% focused on AWS. So what exactly does that mean that we do? We like to describe it across these 4 phases of the cloud journey. So architect, migrate, manage, and optimize. We can help you with everything from planning out a migration to AWS, including roadmaps, proofs of concept, AWS best practices, all the way through to ongoing management of your environment. So once you're running on or in the cloud, including things like DevOps consultation, AI/ML work, account management, 24/7 monitoring and support. And finally, once you're running smoothly in the cloud, which is everybody's dream goal, it's all about continuously improving and optimizing for cost and performance. So Mission's here to help you across all of these things, and we have the credentials to show that we're successful at them. So again, we're vetted and validated by AWS, and that's how we're able to get the Premier Consulting Partner designation, which is the highest tier partner you can be with AWS, and it takes a good deal of effort to get. So we're excited to achieve that, and we're happy to be on the other side of all those audits. We also have a number of different competencies which AWS provides in specific areas, which further speak to our breadth of experience and knowledge. They've looked at our case studies, our methodologies, and validated that we hopefully know what we're doing in these areas. So most notably for migrations, DevOps, and Microsoft workloads, but there's also a couple vertical competencies we hold as well in SaaS and life sciences specifically. So we're also SOC 2 and ISO 27001 audited. I think that's pretty much sums it up. John.
Sure, and I'll go over the very high level, the different types of partners here at AWS. We segment the partner community into consulting partners and technology partners. We try to be as literal as possible. The consulting partners, companies like Mission, and technology partners, I think some of the ISVs and the software databases and hardware vendors that most customers are familiar with. And I think it's pretty modest that Scott said that it was a what was the term you used? A good deal of effort.
Yeah.
I think if I were to be a little bit more specific on that, in December 2020 we had over 100,000 partners in the AWS partner network and 116 premier partners. So in terms of a designation and just how much effort goes into achieving that, I fast math, it's less than 1% of 1% ish, is right. So I think that's a huge achievement. And as related to the managed service providers as well, I don't have the number off the top of my head, but that level of engagement with AWS is extensive. So highly vetted. And I think that the key takeaway from this is just understanding that consulting partners like Mission are here to help bring together the ISVs and understand your environment as it exists today, and help with the decision-making process, whether it be Alert Logic, New Relic, any other ISVs that are currently in your environment. Bring it up in conversation. If you think it's gonna, if you think it's relevant to the conversation, put it in the chat. Ask questions, because that's what Mission's here to help with. So why work with APN partners? I think we've kind of touched on that a few different ways. I think the biggest takeaway from this entire slide is hands-on keyboard and experience. If I had to look at, we can sit and we can look at we have plenty of data to look at, but knowledge, availability, scale, cost, access to funding programs with AWS, becoming that level of a partner really means that Mission is sitting down with the customer to deeply understand the needs, the business requirements, the technical requirements, and kind of bring that all together so that we're all setting proper expectations with one another, and we're delivering on what you as a customer is asking for. So I think that's really, really important for why to work with APN partners. Specifically Mission. So hands-on keyboard, industry experience, deep level of subject matter experts, across the board. Anything I missed on? I think, or I don't.
No, I think you nailed it. We're just here to help, right? However we can, and like I mentioned before, we can kind of help totally across the spectrum of the cloud journey. We've got folks here who have done this stuff literally hundreds, right? Or almost countless amounts of times at this point, especially folks like Lance who've been at it since the very beginning. So we're always here to help. I think AWS would say the same thing. There's no strings attached, no long-term commitments. You can always get in front of one of us. And I guess that's a perfect segue to just this invitation only enterprise activate program is just really designed to help companies like yours get a foundational knowledge of AWS. And again, we're just here to assist however we can in your journey. So you'll have access to AWS ProServe essays, folks on Mission side as well. Various training and certification programs are available. And there's even an opportunity for an assessment of your current environment against AWS best practices, or for us to kind of help assess a migration plan if that's kind of the stage that you're in. So again, happy to help. I would say stick around to the end. There's a special offer for Mission and AWS, and I think we're ready to roll into some of our content. So.
I would say one more thing. Sorry, I wanted to bring up throughout this entire day. Keep thinking about if you were to build to get started, if you were to build a proof of concept, if you were to think about your own internal environments, your own applications, if you were to really just jumpstart, what would that ideal situation look like, and what would that ideal scenario look like? When we talk about proof of concept at AWS, we really do talk about getting started quickly, and getting started with an extremely low barrier to entry, if ideally non-existent if possible. We want to help you move very, very quickly, and we want Mission to be able to help you. So throughout the day, keep thinking about where this applies to what you're building today, and what you can build tomorrow with AWS and with Mission. So I think that's very, very relevant to keep in the back of your mind.
Yeah, well said.
Thanks.
Perfect. I think there's a distinction too between like MVP, right? What's enough to get you all the information you need to figure out how to then move forward, versus like building out the complete end stage, because we can get paralyzed when doing that sometimes.
Yes. Cool.
All right, I think I'm going to stop sharing, and I think Ari's up.
Okay, I think I can start sharing. Well, thanks, John and Scott. That was a great start for the day. Let me share my screen. Okay, awesome. Well, good morning, everyone. Again, this is Ari Mukherjee. I'm a solutions architect with AWS. What you can see on the screen is my email ID. Feel free to send me an email if you need any help. If you have any questions, feel free to add me into the LinkedIn. I'd be happy to help and interact with you. Again, thank you very much for joining our session today. We hope that we could have done this in person and got a chance to meet with each one of you personally and interacted with you. But unfortunately, the time that we are in, we cannot do that. But I'm still glad that we are able to deliver this session virtually. And thanks to the team of Mission for that. And we hope that you like our session for today, and it kind of helps you to make your decisions or help you to kind of accelerate your journey to the cloud and in the cloud. So what I'm going to do today is I'm going to talk quickly about cloud computing. What are the primary drivers that the customers are considering today to move to the cloud? An introduction to AWS, what we offer and what sets us apart. And then I'm going to kind of finish off by talking about the AWS global footprint and what are the really advantages of those. So I'm sure we all have heard about cloud computing. Now, if you think about cloud computing, let's kind of go into a bit deeper into that. So we all know that the traditional business applications have always been very complicated and expensive. And on top of that, the amount and the variety of hardware and software required to run them are daunting. And then you will need like a whole team of experts to install, configure, test, run, secure, and update that infrastructure and maintain those applications. And now the amount of innovation that's going on, and if you multiply this effort across dozens or hundreds of applications that the customers are running, it's easy to see why the biggest companies, even with the best IT departments, aren't getting the applications that they are expecting, or they are having a delay. So which is kind of giving a pause in the pace of the innovation that you want to go ahead with. And this is where exactly your cloud computing comes into the picture. Now, if you think about, okay, what is cloud computing? It's pretty simple. The term cloud computing refers to the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. So what that exactly means is instead of you buying, owning, and maintaining your own data centers and servers, customers can acquire technology such as your compute, storage, database, and other services on an as-need basis. So if you think, this is pretty similar to how we operate electricity in our house. You just turn on a switch, the light goes on, you pay, electricity comes in, you pay till you use the light. Once you turn it off, that's all done. And that's exactly where the cloud computing comes into the picture, and where AWS works, where AWS manages and maintains the technology infrastructure in a secure environment, and customers, they access these resources via the internet to develop and run their applications. And when you deploy these applications, your capacity can grow or shrink instantly, and you only pay for what you use. And that's the main strength of cloud computing. And using this, the customers are able to innovate at a faster pace and able to grow as an organization. Now, let's talk about AWS. So how it all started. So after a decade of building and running the highly scalable web application, which is nothing but your Amazon.com, the company realized that it had developed a core competency in operating massive scale technology infrastructure and data centers. And then they decided, like, okay, let's embark on a much broader mission of serving a new customer segment, and that's your developers and businesses. And now they can use these web services to build sophisticated scalable applications. So now what this means is everything you want to do in your traditional data centers now is at your fingertip with the ability to click a button to run applications reliably, securely, and at scale. And you pay for only what you use. So with this concept, then AWS was started back in 2006 and started offering IT infrastructure services to businesses in the form of web services. And what do you call that also as cloud computing? So that's a little bit of background about AWS. And what we have believed in is that we're going to continue to operate a highly available technology infrastructure platform on a global basis that is designed to be more secure and provides more technology services than anyone else or any other cloud provider. And since 2006, AWS is now the fastest growing multi-billion-dollar enterprise. And we still feel this is just a beginning and there's a long way to go. Now, kind of talking more about AWS, we are a unique company in how we operate. Everything we do, it starts with our customers and we work backwards from there. Our leadership in compute and cloud is grounded in customer obsession. We innovate on behalf of our customers and your needs. So if you see today, 90% of our product roadmap is based on our customer feedback. It's our customers which are pushing on the boundaries of what is possible today and driving us to enable new scenarios and capabilities. And we're going to continue to do that. And we think for a long-term relationship, we want to build a relationship with our customers that outlast all of us. So that's the customer obsession that we have. Now, as I was mentioning earlier, like what are the couple of key primary drivers that the customers are looking into these days to move to the cloud? And these 5 pops out the most of the time. The first one is increased agility. Now, if you think like from a developer's perspective, when we have an idea in our head and we want to build an application, deploy it into a server, test it out, we have to reach out to the networking team, spin up that server. So entire this process takes like a lot of time, and which kind of hinders the pace with which you want to innovate or build new applications. But when it comes to the cloud, you can just deploy an application within minutes, test it out. If it works well, go ahead, move it into the production. If not, you can again start rebuilding in your application and again deploy within minutes. So that's the strength cloud computing provides. Now, with cloud, you don't have to guess capacity anymore. Cloud provides you with an auto-scaling options where you can scale up and down depending upon the traffic that's hitting your website. So instead of like, say, before a holiday season, you think there'll be a lot of traffic, and then you spin up your many of the servers, and you spend a lot of time in building those servers and infrastructure, and then came a holiday season, either that will be used or maybe underutilized. And then post the holiday season, either you can keep continuing to have that infrastructure, which will cost money, or you can choose to kind of get rid of that infrastructure, which will again cost time. But with cloud, you don't have to, and it's just auto scales based on how the traffic is moving through your website. Now, with cloud, you can also move from a capital expense to a variable expense. So what that means is instead of spending our time and money on setting up your entire infrastructure, you pay only when you consume, and pay as much as you consume. And the better thing is with thousands of customers and businesses running on cloud, AWS can achieve a higher economies of scale. And what that exactly translates into is lower pay-as-you-go pricing. Now, if I have to talk about the breadth of services, if you see, since our launch, AWS has launched more than 175 services that you can use to build any kind of cloud applications or workload. And it covers the entire range of your compute, networking, database, storage, machine learning, IoT, and many more. Now, again, with cloud, you can go global in minutes. What that means is you can deploy your applications in anywhere in the world within minutes, and you can better serve your customers with low latency, which provides a better experience for your customers and helps to kind of grow your business. Now, if you see like, okay, what sets AWS apart? Now, customers have selected AWS for years because we have proven ourselves committed to our customers' success. We believe we stand apart in the market because of these 7 factors. The first one is security. Security is always job zero for us. We take security extremely crucial. We believe in a shared security model where the security of the infrastructure is AWS's responsibility, and the security of the data is customers, where you kind of secure your data through different kind of encryption at rest or even at transit. As I was mentioning earlier, AWS has more than 175 services, so that gives a huge range of breadth and depth of the services, and you can use them to kind of fasten the pace of your innovation, and you can use them to build any kind of cloud workloads. We have more than 1 million customers, and that has happened because of our customer obsession and the way we kind of deal with our customers. Global footprint, I'm going to talk a little bit more towards in our future slides about the regions and availability zones, what they are. But as of now, just so you know, we have 24 geographic regions and 77 availability zones across 42 countries. So what that means is you can deploy your application anywhere in the world and serve your customers better. Machine learning, we all know machine learning has become a crucial part in any kind of industry. And if you see the machine learning services that AWS provides, it's more machine learning happens on AWS than anywhere else. And the services that we provide can vary and cater to the needs from a beginner to an expert or a data scientist. So there's a huge range of machine learning services, and I would encourage all of you to kind of go and explore that. We have a huge variety of ecosystem, which consists of our partners. We typically have 2 different kind of partners. One is consulting partners who provides consulting services to our customers and help you to migrate your workloads to cloud and also accelerate your journey in the cloud. And Mission is one of our premier consulting partners for that. And then we have another variety of partners, which are the independent service vendors, who are the technology partners, and they build software. They provide software as a service, which was built on AWS for our customers. And AWS is the enterprise leader, and I'm going to show in our next slide. I'm going to show you the Gartner Magic Quadrant, which kind of tells you where we are in the cloud journey. So this was the Gartner quadrant I was talking about. Here you can see the clear leadership of AWS in the cloud on the top right corner. The infrastructure as a service Magic Quadrant is the longest running cloud Magic Quadrant, and AWS continues to be the leadership in the quadrant with the highest position in execution and furthest in vision top position. Or you look at the infrastructure as a service Magic Quadrant over the years, where you see is that there are few dots on the graph. So what that means is delivering the cloud at massive scale is hard. The bar for the cloud keep raising, and fewer vendors over time are able to keep innovating to provide these capabilities. But we have a proven experience in the space matters, and AWS continues to show its leadership. And this is the 10th consecutive year where the AWS is recognized as a cloud leader. As I was mentioning, to finish with, I'm going to talk about our global reach and talk about regions and availability zones. We have 24 regions across the world, as you see. AWS has the concept of a region, which is a physical location around the world where we cluster data centers. So we call each group of logical data centers an availability zone. And each region consists of multiple isolated and physically separated availability zones within a geographic area. So normally you will see for every region, there'll be 2 to 6 availability zones. Now, what are the advantages of these availability zones? Now, each availability zone has independent power, cooling, and physical security, and is connected via redundant ultra-low latency networks. So what that means is that traffic between the availability zones doesn't go over the internet, but instead go through the Amazon's backbone network. Now, AWS customers who are focused on high availability can design their applications to run in multiple availability zones to achieve even greater fault tolerance. And that's what we always encourage as an architecture best practice, to deploy your applications into multiple availability zones to get high availability and more security. Now, these regions meet the highest level of security, compliance, and data protection. So you don't have to bother about the security of these infrastructure. AWS maintains that for you. Now, AWS provides a more extensive global footprint than any other cloud provider, and to support its global footprint and ensure customers are served across the world, AWS opens new regions rapidly. And now, as you can see in the slide, we have 24 in North America, South America, Asia, Australia, Europe, and the list just goes on. Now, to kind of dig deeper into these availability zones, so the main advantage of these availability zones is it gives the customers the ability to operate production applications and databases that are more highly available and fault tolerant. Now, as I mentioned earlier, we have 77 availability zones around the world, and we continue to add at a fast pace. Now, each availability zones can be multiple data centers, and at full scale can be hundreds and thousands of servers. Now, all these availability zones are interconnected with high bandwidth, low latency networks over fully redundant dedicated metro fiber, providing high throughput and low latency between the availability zones. So what that means is the network performance is sufficient to accomplish synchronous replications between AZs. So when you deploy your applications into different AZs, you can easily replicate and even route your traffic into these two. And all the applications that are deployed in these AZs can also be configured to auto scale so that it can handle the traffic as it comes to your website. Now, these availability zones are also powerful tools for helping build highly available applications, as I was mentioning. And these AZs make partitioning applications about as easy as it can be. And if an application is partitioned across multiple availability zones, companies are better isolated and protected from issues such as your lightning strikes or tornadoes or earthquake or any other of those things. And all these AZs, they are kind of separated by a meaningful distance, but it will be all in the range of 60 miles from each other. So with this kind of global footprint, it kind of helps you to build a highly available and scalable architecture. And it also kind of helps you to deploy your applications in any region across the world, selecting any kind of any number of availability zones in those regions, and helps you to kind of serve your customers so that you can scale up your innovation and help your organization grow. So that's all from me today. I hope it was helpful. I would encourage you to kind of go and explore more into the global footprint and also some of the AWS services that are there. Feel free to reach out to us if you have any questions, or to the mission team if you have any questions. And please do let us know how we can help you to accelerate your journey to the cloud and in the cloud. Thank you. That's all from me, Lance. Up to you.
Okay, I'll take over presenting. You might need to pass control. There we go. Thank you. Okay. So I'm going to continue on from where Ari was talking about, and I'm going to talk about everybody's favorite service on AWS, which is compute. Kind of one of the flagship products on AWS here. Let me full screen this thing. All right. Right, so one of the primary services that customers start leveraging when they're looking to move some workload to AWS is EC2, or Elastic Cloud Compute. And so it's essentially it's comparable to a virtual private server, or a VPS, in which you can spin up compute nodes, servers running an operating system of your preference. Can be Windows or Linux or any sort of variant of those. There's a whole community and marketplace out in the ecosystem around different operating systems that you can run. And you get full root or administrative access to these machines that you can launch. In addition to full access to the OS level itself, you can pretty much manage all the infrastructure that's behind the scenes there. So the networking, you have full control over, can change and manage the network interfaces attached to the server. You can attach network storage to the machine, and all of these things are scalable and adjustable. And so over the past few years, this service has really evolved. In addition to just a standard server deployments where we're launching these EC2 instances in either a static capacity or in like some sort of scaling, auto scaling capacity, there's new services that AWS has been developing, similar to other cloud providers, around this similar kind of the same kind of compute element, but more kind of bite-sized. Customers are able to take their applications and upload them and deploy them in different ways. So using services such as the Elastic Container Service, the Elastic Kubernetes Service, and Fargate, which is a component of ECS mentioned there. So that's really a service around using container technologies like Docker, and being able to build an image of your application or thing that you need to run, and be able to publish and orchestrate containers in a system. And so there's different ways of operating these types of workloads. You can still run and host all this compute yourself, or you can run and manage services and just let Amazon run your containers on your behalf, and they'll be responsible for finding the appropriate infrastructure to run those containers on. And the third thing depicted there is Lambda. So this is even another higher level abstraction of application infrastructure. It sits somewhere in between app and infra, in which there's an API interface where customers are able to upload their code, whether it's like a Python thing, a Ruby thing, a Node.js or JavaScript thing. There's different programming languages that you can work with this service, but essentially customers are able to deploy their code to AWS Lambda and be able to invoke functions. They can sit behind load balancers, they can sit behind cache and CDN endpoints. They're all the same sort of logic that you would see. Rather than normally hitting a server that you want to control, you can offload all of that to AWS. So it's really a performant way to run a scalable workload. All right, and so lots of options to choose from in terms of the services that AWS offers here. But to talk more about the kind of core thing there around EC2, in addition to kind of the various operating systems that you can choose from, which I had mentioned already, there's also a lot of options around the actual hardware and the architecture under the hood. Right, so different, you have a choice between different series of EC2 instances, different networking types, different launch types, different ways to purchase the capacity that you need for a workload, and different ways to even leverage spot markets and ways to run compute cheaper than you normally would. So, just to kind of briefly cover some of the terminology involved here, we had touched on the availability zones, or AZs, a bit during Ari's talk. But how the AZs come into play here is that when launching an EC2 instance, you're basically choosing a pre-built configuration, or either a person or an organization has created it in advance, or you've taken a base operating system and installed custom software and configurations onto it. But the kind of end result, or what is needed to be able to spin up additional machines with pre-built software, is what's called an Amazon Machine Image, or an AMI. Some people even call them AMIs, but I never took hold with that one. But essentially, you get a deployable image which you can spin up new machines, and it can be a point-in-time snapshot from like a backup and restore perspective, or it can be a published image. Most of the marketplace, if you're looking to download and run some sort of prepackaged software, these are being distributed to you all as AMIs, which you can just launch into your account. And now you get a machine running that software built in. So we're going to expand on this in later topics, but just to kind of cover it briefly, there is a network storage capability, and it's called elastic block storage, and it's essentially drives that you can attach to machines, and you can scale the size of the drives, the IOPS, and the speed and the performance of those disks. And these can just be mounted to a machine, and just like in any other situation, if you're on-prem with hypervisors, you attach some raw storage. You'll see in your logs on that server, new disk is attached. You can format it with a particular file system, mount it to the machine, and begin reading and writing data to that disk. So on top of those things, S3, which we'll also cover in the upcoming storage segment, is kind of the backbone for a lot of the storage infrastructure on AWS. There's the common interface that most of us see and work with, which is S3 buckets. Just the object storage, where you can upload files, or just kind of data as individual objects. But the under the scenes thing is that storage infrastructure that's very highly available and has that global footprint is the backbone for a lot of these other components as well. So when making EBS snapshots, those things are natively taking advantage of that S3 infrastructure. That's not to say that you can view and interact with snapshots through S3. That you interact with them from different places, but it just kind of goes to show the massive storage infrastructure behind the scenes there. So there's a ton of options to choose from when looking at like the processor architecture. The kind of the classic one that most people have been running for years and years has been Intel. But as workloads have evolved and customers are doing different things on AWS, there's been a different need for different architectures. So customers in like rendering spaces, or with a need for GPU, there's NVIDIA options available, and so you can run high intensive GPU workloads on AWS and take advantage of the GPU offerings there. AMD being probably the biggest competitor to Intel, you're able to run various types of AMD processors for your workload. And the kind of on the far right there is the newest series, which is Graviton's ARM-based processor. So there are a lot of customers who are taking advantage of the performance benefits, and in some cases, customers are custom coding their software to work with some of these architectures just because it unlocks the right blend of performance for them. So when it comes to the actual instance type, there are different options to choose from, and this really comes around both the sizing of the server, right? So that like the virtual CPUs and the memory that's associated with the server, but also the hardware under the hood. And so there's a whole different blend here, as this spectrum is trying to show, for the various types of workloads that customers will have. So it depends on the workload involved and what those servers are there to do. But there is a use case, or I'm sorry, there is a flavor for any use case here. All right, so customers, say you're running a Java application, which is very, those Java tends to be very memory hungry, and bind a lot of memory on a server. All right, the customers running those sort of workloads, they're typically going with a memory optimized instance type. So when they're rolling out auto scaling instances or just launching EC2 machines, they're picking the memory optimized types and working with that kind of subset. And you can review all through the left and right of the spectrum there, but there's compute and memory intensive. There's the FPGA, which I always forget this acronym. Field processor grid array. I probably botched that. General purpose GPUs, all sorts of like graphics intensive things. High I/O for customers doing like high intensive compute operations or like clustered machines where they really need that raw performance. And then all the way through, you get the burstable T3 series, which customers typically use in development and staging environments, and the general purpose, which is just kind of a blend. You're not taking a stance one way or the other. I think the newest one on there is the Mac. I believe that was announced at reInvent. But for customers who are developing software for OS X in particular, you can now launch Mac machines and be able to develop and test and run applications on actual Mac instances there. So all of these things are kind of interchangeable, right? And that's kind of the power of EC2, in that there is a flavor to suit your workload. And all it takes is a little bit of research to figure out which is the best. And fortunately, with the cloud being so agile, you're able to change all of these things on the fly. So if you roll with a particular instance type, you're not really bound to stay with that one forever. You can switch gears, you can package up your server as an AMI, you can launch it again as something else, and all of this is intended to be very elastic, and you can kind of slice and dice and duck and move. So the instance sizing here is kind of representative of the different sizes of workloads that you can pick from. I think one of the best things about this approach is that for customers who are used to vertically scaling, right, when they need more capacity, they're just taking an existing machine and making it larger. Really, the power and the flexibility here is that you actually get more performance, you get more benefit out of running many smaller machines and scaling horizontally. And if you review the pricing for these different instance types, you'll see that it's pretty much matches with the price of a 4x large there is exactly half of an 8x large there, like you'd expect. And so this gives customers the flexibility. They're not stuck paying for very large machines if they don't need to. The smaller you can slice your workload into small machines that you can horizontally scale, the more easily you can manage the kind of the billing operations of that workload, right? And so if you've got an 8x large machine that's sitting there idling most of the time, but it's busy for a certain part of the day because it's running some jobs or it's doing something, with AWS and EC2, you're able to break that out into many smaller machines, and you can scale it down when you don't need to. You're paying for the price of an X large there. And when you need the performance of an 8x large, you just spin up 7 additional machines. So again, all intended to be very, very flexible here. As you're researching options and looking into what instance family should I choose, what should my sizing be, you'll see this pretty much everywhere. The syntax or the format of the instance sizing. And so this slide is basically just calling out what that syntax actually is representing here. And this will be the representation that you'll see in both in the console and in the documentation. right? So if I'm working with, a development environment, it's probably going to be like a T3.medium instance, or, for smaller stuff, you maybe see like T3 micros and stuff. So there's, this syntax is useful in determining, and what a size or attribute or family a certain instance is in. So I touched on the operating systems a bit already, so I'll kind of breeze through this slide. Pick your flavor, it's available in AWS, even if you're into some niche stuff like me. I'm partial to like FreeBSD and OpenBSD, those old school Unix systems. You can find images out there for those things. Most Windows versions are supported, most Linux versions are supported, whether it's Ubuntu or Debian, Fedora, Red Hat, CentOS, and kind of one that's kind of in my heart has been Amazon Linux. Right, so Amazon basically took I believe it was based off a CentOS distribution, and they customized it and tweaked it for maximum performance on EC2. So Amazon Linux is a very common OS that customers are launching for their Linux-based workloads. Alrighty. There's a bit more content here, but I actually want to switch gears and I want to get to the lab. I'm partial to actually doing stuff on the cloud, so I'm going to switch gears and we're going to pull up the lab. So I'd also like to call out, if at any point in time throughout the conversation today, if you all have questions, feel free to use the little chat bot or the chat component in GoToWebinar on the control panel. Or if you have any questions, there's a little question and answer panel there as well. Please, ask questions, reach out if you have anything that you want to bring up or say. We're kind of standing by and waiting for some questions to be hit in there. So with that said, I'm going to switch over to a lab. So everyone should have received this document. So this is the EC2 hands-on lab. We're essentially going to launch an EC2 instance. It's going to be a Linux machine. We're going to leverage some of the native scripting and automation components of AWS to launch that machine and have it automatically configure itself. We're going to spin it up, wait for it to come online, and we're all going to be able to connect to the web interface of that machine and see a little custom app that the thing is running. So everyone should have received a link to something called Event Engine. Looks like this. Eventengine.run is the domain. Dashboard.eventengine.run. Should have been a link with a custom hash or in the URL, and it's essentially going to give you access to a sandbox account that you can spin up. So there's a couple interfaces here. This is for a command line base if I want to use my terminal, which I plan on using in a couple minutes here. I can pull these tokens and get access to there. But first, I'm just going to use the console. So the console is, one of the primary ways that customers are interacting with their AWS environments. I would say that this is how most customers start out, but the trend and what we've seen is kind of the best practice over the years has really been to define the infrastructure that you want to run as some sort of code. There's a handful of tools out there and services and systems that help you do that. And probably the biggest call out there is an Amazon service called CloudFormation. Right, so using CloudFormation, customers can define their infrastructure, so that can be VPC, network infrastructure with subnets and route tables and access control lists, security groups, and even all the resources that are available on AWS for you to launch, deploy, and configure. You can do so with CloudFormation in like either JSON or YAML format. You author these templates. You can launch stacks in the console. You can launch stacks using command line tools. You can write your own custom tools. There's a bunch of open source things out there. This is one of the main ways that customers today are managing their infrastructure on AWS. Very powerful service. But we got to crawl before we can walk, before we can run. So we're going to work in the console today. So I'm going to snap my windows side by side here so you can watch me. You're more than welcome to get access to that lab environment and go through this document yourself. You can follow the doc to the T. You can watch me and imitate what I'm doing. You can only just watch and just kind of leave your lab empty, or you can just play around in that environment, which I always prefer to do. I spin up a box, download the SSH key pair, get access to the machine, and play around a little bit in this little lab environment. Hang on, let me close a window real quick here. All right, I'm back. Okay. So the first thing we're going to do here is create a key pair, right? So any machine that you launch, whether it's Windows or Linux, you need a key pair. For Linux, that key pair is going to allow you to SSH into the machine, right? So that's the management protocol that Linux uses to be able to manage a system remotely. For a Windows machine, you'll actually use that key pair to decrypt the administrative password, and you'll be using RDP, remote desktop, to manage that machine remotely. So I kind of glossed past it. When you first get into your console, you're presented with this. I'll go back to it. This interface where it'll show you all the services you've used in the past. This interface is constantly evolving. The current iteration, though, you have this really handy search box. I just go in there and I type the service I'm looking for. So let's go to EC2. And you'll notice there's a lot of stuff going on in EC2. I'm going to collapse all these things and just kind of show you around real quick. The dashboard is kind of the high level view where you can see the raw counts of the things that you've got running. Under key pairs, you'll notice that it already says one. Part of this event engine service, which we're using to spin up these lab environments, it's going to preload a key pair for us. It's kind of handy. But of course, we can always spin up another one. So I'm just going to say Lance, immersion day. I want a PEM format. If you're on Windows and you're planning to use something like PuTTY, you may want the PPK there. It just depends on your box. I've got a OS X machine, kind of native Unix-y thing. So I'm just going to download a PEM format key, and that's how I create a key pair. You'll see it there. There's the fingerprint and the ID associated with it. And with that, I can now launch an EC2 instance and be able to, where is my, cool, just making sure my share is still good. So if you're kind of outside of the dashboard, if you wanted to find where the key pairs are, you look on this kind of left-hand bar that scrolls up and down and go under network and security, and under there is the key pairs page. So I've already downloaded this default one, but just for the sake of the lab, I made a new key pair and downloaded it. And so now let's kind of move forward into the lab here. And we're going to actually launch the instance now. So I'm going to go back into, not the dashboard, but I want to go into the instances section under the instances panel. So nothing's running here. It's an empty account, not much in it. I'm going to click the button here to launch an instance. So this is kind of the default page you see here. These are some of the built-in operating systems available for you to spin up. It's part of the quick start panel. So these are things that AWS is authoring and making available to customers. So you'll see Amazon Linux 2 is the top of the list here. So again, that's the Amazon's custom Linux distribution, I believe based on CentOS, Yum package management. If you scroll down, so we got Red Hat, we've got SUSE Linux, we've got Ubuntu, Windows, and all sorts of different AMIs for different things, right? So deep learning is going to come preloaded with software like PyTorch that helps customers run neural networks and train machine learning algorithms, Debian, all different Windows flavors. And really the main thing here, you can search for the thing you like. I like OpenBSD. I wonder if there's any there.
What also is cool is, I don't know if
Um,
you touched on it yet, is the community AMIs. You can make an AMI and publish it, and other people can go and grab it and deploy it.
Yep, exactly. And so a lot of like open source projects will share AMIs in this way. I did a quick search for OpenBSD, which I'm partial to. Let's do FreeBSD. And there's none available like by default from AWS, but there are quite a few in community and some in marketplace as well. So, all right, I can nerd out over that stuff. But for the sake of the lab,
Lance,
I'm Amazon Linux 2.
Lance, can we quickly check if everybody is able to log in to the lab and get to the console?
Sure. I guess they don't have a way to audio, but can anybody let us know if they cannot access the lab and they would like access to the lab? I'll stand by. We'll stand by in case anybody has a problem, but I'm going to continue and assume that everybody's good to go.
Hey, Ari, I was just curious, what's the self-destruct timer on these lab accounts? How long will people be able to access
It's 72 hours. So for the next 3 days, everyone will have access to it in case you want to explore by yourself. But after 72 hours, it will terminate.
Cool.
72 hours of unfederated AWS access. Have fun.
Go crazy. Okay, so I'm going to use the Amazon Linux 2 AMI that was top of the list there, and just with the default configurations. So the lab is, suggesting T2 Micro, which is the default or kind of the already highlighted one. So I'm just going to continue there and go next. And so a lot of details here. I would urge you to kind of stop and check some of these out, but I'm just going to continue with most of the defaults here. In a real scenario, you may want to be putting your servers in private subnets so they're not accessible over the internet, and having some sort of thing in place like a VPN that allows you to connect remotely to the network, and then from the VPN you can admin and get to the other machines. But for this lab, we're going to use the default VPC, which is available in all the regions. There's always a default VPC that you can start out with. All of the subnets in a default VPC are public, so it doesn't matter which subnet it ends up in. So I'm just going to say no preference. Regarding like assigning a public IP address to a machine, there's a setting where you can just rely on whatever the subnet's configured to do. In this case, that's enabled. It's a default VPC. And I'm going to scroll down so we don't get confused by all the options here. But the one thing that has to happen here is down at the very bottom under advanced details, there's this thing called user data. So if you're a sysadmin like me, user data is going to be very important to you. So this essentially allows administrators to run scripts on that machine when it gets launched. So for a Linux instance, that's going to be like a bash or a shell script. For a Windows instance, that's going to be a PowerShell script. But this is what allows, this is kind of the initial entry point into automation. Even if you're using something behind the scenes like Chef or Ansible or Puppet or Salt or some sort of configuration management tooling, user data is still usually involved because you've got to get that config management software installed somehow, or there's usually some bootstrap process involved, except for Ansible maybe. But user data is usually coming into play for customers who have more advanced needs than just spin up a box and managing it manually. Any sort of automation, you need user data. So what this lab is referencing here, we're going to copy paste this little text snippet, and we're going to paste it into the user data field. So this, if you ever worked on a Linux system and you're familiar with shell scripts, you'll recognize this file extension right away, this .sh. But this format might be new to you. This hashtag include or pound sign include. This is basically a syntax for cloud init, which is pretty common on even hypervisors on premises. But this syntax is essentially saying, fetch this script and then run it. And if you pull it up, you'll see it's a little shell script that's going to install a web server. It's going to install, I think, a little PHP application. It's going to set up the web service environment, and then it's going to run those things. So when this instance comes online, it's going to execute, it's going to fetch and execute that script. And when the public IP address becomes available and the machine is on, we'll be able to hit the web interface and interact with it. So I'm going to go to the next page, which is storage. I'm going to leave the defaults here, but feel free to check around at the options. And now tags. I am going to add a tag. Tag name is usually the minimum there, but customers can add lots of tags for different departments or teams or applications, environments. So let's call it the Lance ID, just like I called that SSH key pair. Next, we're going to security groups. So the security group is somewhat of a firewall. This is basically a rule set that is associated with a network interface or a different service that you can assign a security group to different things. And this is basically networking rule sets. So in this case, typically I'd lock this down to my IP. For the purposes of the lab, we'll say anywhere. For SSH, because that's how we're going to manage the machine. And we also want to run, we want to open up HTTP because this thing is going to be running a web server. We can tag a description. We're going to open up access to the world here, and we're going to review the system before we launch it.
We're going to cover security groups a little more in the security section of the presentations today, but they are very important and they are required. You cannot launch a AWS EC2 instance that isn't a part of a security group. And a security group is essentially a software firewall.
So when I go to hit launch here, you'll see this prompt and it'll show which key pair you want to launch with. I'm going to choose the new one that I just made, just to show the full example. Then I'm going to launch it. So from here, you can hit that bottom button to view all the instances, or I like to click this little link here, and that'll set up a filter so we see that machine specifically. But once we're back in this view, we're viewing all of our instances, we'll see that this thing is in a pending state. And if we click onto it, it'll select it or highlight it, and we can scroll this little bottom pane up, or you can use this little quick jumper thing. But this will show us all the details of this machine. So tons of options here, things to, plenty to review and get familiar with. But the main thing we want to see here is this public IP address. So now, since this machine is now running, it's coming online, it's essentially going through that user data script and installing its packages. I think it's going to be like Apache web server, running a PHP application. And in just a minute, we should be able to hit the web interface, port 80, and see this website. I wonder if we can see the log yet. Nope, not yet.
I think that takes a bit of time to aggregate.
Yeah. Well, it looks like it's kind of ready. Got a dead link. Oh man, AWS moved a logo. Well, the logo doesn't load, but the web service still comes up. So as I mentioned, look, we had Apache web server running a PHP application, happened under the hood, behind the scenes through our user data mechanism. One kind of cool thing about this little PHP app, just this little sample thing, it's got this little load test thing. I'm going to click it. And so now, on this page, the PHP code behind the scenes here is basically just acting busy. It's just going to do a lot of random IO tasks to purposely drive up the CPU. This is not referenced in the lab, but just is something I wanted to showcase here. When viewing this instance, and we can see the details here. We got all these tabs. One of the things that most resources on AWS will have available is a little monitoring component through a service called CloudWatch. Now, I did just spin up this machine, so it's going to take another minute for these metrics to start populating. But this is how administrators can get a high-level view of their system. Right, so in a minute, we'll be able to see CPU utilization. We'll see it spiking because this thing is going through its load. And in addition to these other metrics, right? So network, disk, status. Another interesting thing here is that on this page, we're able to see this instance ID. If I go back over here and I search and compare, there it is. All EC2 instances have something called metadata that they can reference from their machine, and it's useful for administrators to be able to reference metadata, either on the machine itself doing some OS configuration thing. It could be useful if you want to take a backup of a system and you want to capture, what region the thing is in, or the instance ID, the availability zone. You can capture this metadata and upload backups to S3 with this unique kind of footprint, right? So you can store it. You can store backups and be able to reference what machine the backup happened on. But there's a lot of interesting things you can do with the metadata there. So now the lab does not cover utilizing this SSH key pair. You do need one to launch the machine, but it doesn't talk about using it. But since we do have 5 minutes, I'm going to do it. So I already got the, no, I don't. Let me go back into the details and grab the public IP here. It's now on my clipboard. And I'm going to bring over my terminal. Actually, I want a different terminal. So I'm in my immersion day directory. I want to download the, I think called it lanceid.keypair. Move it here. We're only going to set some permissions on the key pair. And now I want to SSH to my machine. This is the IP address. This is an Amazon Linux machine, so the user is going to be EC2-user. And the key pair I want to use is called lance-id. So we should hit a prompt. It looks like we hit the port, did the fingerprint check, and I do want to continue. So let's get access to that machine. So now I'm running an interactive SSH session with this EC2 instance that I've launched. Let's see, let's get curl. We do. So part of that metadata stuff I was referencing, there's this kind of unique, funky IP address that is innately built into the system here. But when you are interacting with this metadata service, you can query this IP address and be able to reference the metadata. So back in this web service, the PHP application is actually just it's reaching out to this IP address and fetching the metadata. Let me just poke around in this box real quick. I want to see what that shell script is. wget. I do. Let's download it and read it. Here was that user data script. So, again, Amazon Linux, CentOS derivative. So it's got the Yum package manager. Part of what that user data did was use the package manager to install HTTPD, which is Apache, PHP, MySQL, and the MySQL interface for PHP. Funky little case statement here, but this is basically turning on Apache web server, enabling it on system boot, starting the web server, and erroring if the OS doesn't support these commands. If script is going to check if this tarball exists on the system, this little tar.gz thing. If it doesn't, it's going to fetch it. So it looks like there's another thing that the script fetches on top of us fetching the script. So it's downloading this kind of pre-built PHP application, in this tar format. It's going to extract it and it uploads it to, or extracts it to var www html. It does a yum update. And so since that's the default location for Apache web server, we can go check it out, list the contents. Let's look at that index PHP. That'll show us how they're doing the metadata thing. Oh, it includes this one, get metadata.php. Nice, check it out. So you saw me use curl on my terminal to interact with the metadata. This PHP app, like I mentioned, is referencing that same IP address, 169.254.169.254/latest/meta-data. And from there, it's taken this base URL and referencing instance ID. And then also same thing for the availability zone. So if I do that without PHP, I'll probably curl this endpoint and then instance-ID. My terminal is kind of weird here, but I can curl that endpoint and there's my instance ID as seen here. Right, so that's essentially the lab. Hopefully you're in that lab environment and you're taking advantage of this lab thing that you got going. So feel free to poke around on the machine if you launched one, on the account. It's useful to click this drop down in the web console to view the AWS services. There's a ton. We're going to stick to kind of the core services today, but I would encourage you all to get in there and just start tinkering and looking around and finding things that interest you or maybe applicable for some type of workload that you're looking to run. I've been doing administration of systems for a while, and kind of the services that excite me most are the Elastic Container Service, which we mentioned on our slide deck, and Lambda. All right, so I'd encourage you to go into these things. Most of the services have a built-in demo that when you go into the service and you click buttons like Get Started, there's samples, right? So I could launch a sample containerized application in ECS and just launch a service in a cluster. Looks like it's going to run it in Fargate, which we had touched briefly. So by going through this, you'll have a Fargate cluster with a load balancer. You'll be able to hit a web service, and you're not even running any EC2 instances. It's just all happening as part of ECS. So pretty cool stuff. Go check it out. Until then, we're going to take a quick break. So the time now is 9:22 Pacific. So let's take a 10-minute break and come back at 9:32 Pacific. And please adjust to your time zone. And if you're sticking around, you're not taking a break, ask us any questions if you got any, or let us know if you got some feedback or something you want to share. I'm going to go take a break now. See you shortly. Alrighty, we're back, getting there. All right, I'll give everybody one more minute to get back to their desks. And in the meantime, I'm gonna delete that instance that I had made. Or terminate, rather. And when it's done, I can delete the key pair. Alrighty. So the next section we're going to cover is storage on AWS. So there's a few components under this which we're going to cover. So the first is just going to be kind of a primer on storage systems and the options on AWS. And then we're going to talk specifically about block storage, shared file systems, object storage, and your options for integrating with on-premises storage solutions. So this is kind of an outline of some reasons why AWS is a good choice for your storage needs. You know, one of the biggest is the cost. Everything is pay as you go. You know, you're not locking in hardware. I mean, you can. That's an option to you. But for the most part, customers are utilizing some sort of pay as you go method where they're really only paying for, you know, the runtime of or of a database, or you know, the availability of some block storage. You know, so there's not a whole lot of capacity planning requirements around it. You know, you just like we did in the lab, you can go to the console and spin up any storage components that you need, utilize them for the time that you need, and delete them when you're done. Just like you saw me delete that EC2 instance just now. You know, you're only ever paying for something if it's actively in use or provisioned and like making use of Amazon's infrastructure. Everything's really easy to manage. You know, most of customer storage needs today are provided as managed services to the point where you know, you don't need DBAs on hand to manage your RDS, your relational database service, because it's a managed service as it is. You know, it's you know, very easy today to be able to manage, you know, even complex workloads using AWS. And for the customers who need it, there's SDKs and integrations that you can custom code. You know, you can write your own scripts or application logic to interface with AWS's cloud platform. You know, the risk is low, right? The storage options on AWS are very durable and secure, and the security is of the utmost importance at AWS. And you know, all the customers, you know, globally know that, you know, they're in charge of their workload and the configuration of their security groups and the networking and security on that layer. But AWS is responsible for securing the actual data centers, and those things are locked down, you know, state-of-the-art data centers there. And kind of the last topic there is really around the speed and the, you know, agility and the scale. So like we talked about in the first slide or the first presentation, AWS is massive and global, right? So I think it's at 24 regions and 70 plus availability zones. It's, you know, and it's not like those things are static and set in stone. They're constantly new regions and AZs being brought online. It's actually hard to to capture and track. If, like our slide decks are always out of date. I bet this one even is. Right, so there's just always new places coming online, being lit up. with that solid backbone, and it gives customers the scalability. You can run databases anywhere in the world. You can scale them out. You can set up replicas. There's a ton of different ways to slice and dice your systems and run very scalable storage workloads on AWS. So with that being said, let's get into a quick primer. So before we talk about the services, let's just go over some storage 101 type stuff. So there's three different models here. The first is block storage, right? So if you've got a hypervisor on premises, maybe you're running VMware, and you've got like a SAN, and with that SAN, you've got an array of disks attached. You can kind of slice and dice the data, as part of the overall array, and assign it to many virtual machines or different parts of the system. But what block storage is basically just raw storage. You can attach block storage to a compute instance, like an EC2 instance or a virtual machine. You attach raw block storage to a machine, and from there, on the server, you can interact with that raw storage. So you can format it to any sort of file system that you need, and mount it anywhere on the file system and interact with it. And then you can detach and attach that block storage to any other machine, right? So in my EC2 lab, if I were to set up some block storage on that device or on that server, and I put in a text file that said hello world, and I detached that block storage and I attached it to a different server and mounted it on the file system, I'd have that same exact file in the same exact format. So block storage is kind of the underpinning there for most virtual machine storage. The other option is it's really built on top of block storage, is file storage. So this is really more of a direct network attached file system. So in the Linux world, this is something like NFS, network file system. AWS has an equivalent service called EFS, Elastic File System. Same protocol, same premise, but it's just managed by Amazon. In the Windows world, there's Windows file sharing through server message block, or SMB. Right, so when administrators in a Windows environment are setting up file storage components like this, they're usually setting up shared drives or networked drives, right? So that's how you get like the extra Z drive, where corporate networks are able to store their files and whatnot. And so this is basically block storage assigned to a file server with a formatted file system, which is then being shared as file storage to other machines. So that one's kind of a layered approach there. And the third there is object storage. So there are some tools and systems out there that take advantage of object storage. The main AWS offering that we talk about, when object storage comes to mind, is the Simple Storage Service, S3. And so it's really, rather than a native file system endpoint where you mount it to your machine, it's really an interface to a bunch of objects, and you interact with it through an API. And so this gives a lot more power and flexibility than the traditional file system permissions model. You can set up very granular permissions around object storage, around who or what is allowed to access which object or path. It's all policy driven. Right, so typically workloads make use of a blend of these different storage capabilities. So these are some common characteristics when assessing a storage solution. Right, so durability is a measure of the expected data loss. If in the event of some outage or incident, the rating of a durability of a storage system will typically show to you, what any expected data loss might look like, right? So typically, this is where you'll see something like 99.99. It usually comes down to like number of nines, 2 nines or 6 nines or whatever. I don't want to read the rest of these, so we'll just kind of run through. So we got availability, security, cost, scalability, performance, and integration. Right, so all these characteristics are things that customers running workloads need to keep in mind, and figure out the right blend or mixture of services to suit their workload and get like the performance that they need at the cost they need with the security they need. So all these things are kind of blended together, and you got to find the right mixture of these things. I'm gonna breeze past some of these things. I don't want to talk about these. So I want to talk more about the actual services that are providing these values, or these value-added things. So the first one is a block storage service, but it's called EBS. So it's Elastic Block Storage. And this is basically the underpinning for EC2. When we launched that EC2 instance, there was an EBS volume attached to it. If you recall in the lab when we're going through the wizard, one of the options there for us to choose from was the storage, right? And so by default, it was I think it was a GP2, like an SSD disk that was attached that had 8 gigs of storage. So because it's coming, preloaded with an AMI, it already had a file system and the operating system installed there. But typically, back in the console, you can go launch an EBS volume and allocate a certain amount of storage. You can set different configurations on the IOPS and the performance of it. But through EBS is how you can then attach different block storage to your compute instances. And it is not many to many. You can't attach one EBS volume to many EC2 instances, but you can attach many different volumes to an EC2 instance. And of course, those can be attached and detached and moved around. There's a lot of options and capabilities when it comes to maintaining data on EBS. So these are some of the features. EBS was designed for 99 and 3/9 of reliability. And it's redundant across multiple devices within an AZ. When you launch a volume, it is limited to one availability zone. So back to the region versus AZ model. AZ is essentially a data center within a region, and when you're launching a volume, that volume is essentially going to be isolated to the AZ it's launched in. So if I launch a volume in AZ A, I can only attach it to instances also in AZA. And then to move stuff around, you can basically copy and launch new volumes from copies, and be able to spin them up into other AZs as needed. But another kind of important factor here is that they're secure. There's policies that you can put in place outside of the default ones that allow for not only enforcing things like encryption, but also around the access and the management of EBS, right? So you can set policies that allow or disallow administrators or operators, people in a console, from doing things with volumes. And there's different sorts of permissions that you can apply in terms of the management of these things. So administrators are able to set up a robust deployment around, not on top of EBS, but then have granular control over who or what is allowed to do what as it pertains to EBS. So they're scalable. We didn't really touch it much in the console, but at any given point in time, customers can go to an EBS volume and increase the storage. You will of course need to then, at the operating system level, go interact with that storage interface and extend partitions and ensure that you've got file system coverage on the whole thing if you go add storage after it's already provisioned, but you have the ability to do so. And of course you can spin these things up as quickly as you can delete them, and it's really there's nothing kind of cemented or concrete about them. You can spin them up on the fly, load them with data, move data sets around, and then spin them down, delete them when you're done. And they're very fast, right? So out of the box, a lot of customers are just leveraging, the default uh, option, which is it's called GP2. There's a new one called GP3, which is becoming the default. It's cheaper, it's faster, and it gives you operators more flexibility. But out of the box, it's very fast. And usually only for customers with absolutely strong performance requirements that they'll leverage one of the more enhanced IOPS disks. But out of the box, like the defaults are very performant. So, EBS volumes are network attached, right? So they're basically operating out of a storage array, and you can snap them onto different EC2 instances and interact with them. Just like a network resource. Like I mentioned before, you can only do one instance at a time per volume, but you can have many volumes per EC2 instance. And they are interchangeable. You can remove detached volumes from one instance and attach it to another and still have access to the data on that machine. Right, and so any sort of deployment or option that you need, and as long as you need raw block storage, EBS has got you covered there. So I did touch on the volume types already, but this slide shows more of the options that are available to you. So the default is usually SSD, most common deployment option. Some customers are leveraging hard disk drive, the spinning platters for more like cold storage. There is like a throughput optimized version, but it's usually for lower cost reasons. You don't need the data to be as hot or as fast. And this is kind of the breakdown of the types split between them. This slide does not show GP3 because it is fairly new, but it's kind of the newest version of general purpose SSD. It's a bit more flexible, somewhat of a mixture of GP2 and IO1. So with the provisioned IOPS SSD, that IO1, out of the box is very performant and fast, but operators essentially choose the amount of IOPS they want for the disk. And kind of back to the pay-as-you-go thing, you're essentially paying for whichever IOPS you've specified for the disk, and that's a scalable, an elastic thing that you can change at a moment's notice. So if you are going through some event where you'll need lots of performance, you can scale up IOPS on the disk. You can scale up, the EC2 instance and beef things up. You can do any sort of processing, and then when you're done, just set it all back. And this can all happen. This all can be automated, since everything is essentially an API here. So these are some use cases or why you might want to use one or the other. So SSD is a pretty popular choice for, it's used for most workloads, but especially, the provisioned IOPS disks for databases and situations where you need just pure speed performance, right? You've got a database with tables that you're issuing SQL queries to and doing lookups on relational data or even non-relational data. But the use case is typically for software that needs to be fast. And for the use cases around the spinning metal platters is more around usually for cold storage. You just need a file system, you need some block storage to hold data, but it doesn't have to be particularly fast. It can kind of be slow and steady, and you're okay with paying less for that need. So typically we'll see deployments around like Kafka, Splunk, so data analytics workloads. And then also for some file and media type of workloads. So in transcoding and encoding jobs where it can happen in the background. There's not a whole lot of urgency behind it. It can take its time. And again, it's that kind of blend on price point and performance. But the nice thing is that you have the flexibility and you have the option to do so. When it comes to backing up data and like maintaining data on AWS, and especially through EBS, since that's the service we're focusing on right now, One of the main ways that customers are maintaining backups of their data is through EBS snapshots. So it's basically a point in time snapshot of the underlying block storage. So kind of similar to other storage engines or file systems like ZFS, if anyone's familiar. You basically get a point in time of that disk, whenever that snapshot was taken. And so this can be set up to happen automatically and recurring to various intervals depending on your needs. But it's pretty common for customers with stateful data relying on an EBS volume to have snapshots in place, so that if there's ever an issue with the machine, or some data gets corrupted or deleted on accident, or even crypto lockered or something like that, customers have EBS snapshots available to be able to restore volumes from those snapshots and then attach those volumes in. So there's a couple different ways to set up snapshots. There's a native interface within EC2, but there's also a service on AWS called AWS Backup, which is kind of a one-stop shop for all your backup needs. And part of that service, part of what it can do is ongoing EBS snapshots. All right, so let's talk about that second storage option there, which was file system based. All right, so Elastic File System, or EFS, is Amazon's managed service for NFS, which is primarily Linux-only technology, network file system, or it's like a kind of Samba, CIFS-based, but this basically provides a canonical networked file system that can be mounted on machines. So it's pretty common for deployments where you have a large data set that needs to sit on a file system, and you have many servers which need to interact with that data. And since you can't mount EBS volumes across many machines, and the underlying system or application is unable to take advantage of an object storage like S3, and it's all based upon file system storage, usually like a legacy application that needs something like this, EFS comes into play. All right, so essentially, kind of how we did in that lab, one of the most common ways to set up EFS is to utilize user data and set up automatic mounting of EFS shares on that system. And so it can be set up on boot. You can set it up to mount manually if you wanted to, but you can essentially mount a file system that Amazon is managing on your behalf, and the thing grows almost infinitely. I say almost because infinite is not possible, but it's petabyte scale. You're able to just start with a share with 0 data in it and throw data into it, and it'll continuously grow and grow forever, for as long as you're willing to pay the bill for all the data that you're storing there, until you evaluate other storage options or prune or delete data. So within this EFS service, there's a lot of different configuration options and settings. Similar to an EBS deployment, you can choose different performance levels. You can choose different storage options, so things like infrequent access. You can basically pay less to get a little bit less reliable or durable storage on EFS. The most common use case I've seen here has actually been around auto scaling deployments of EC2 instances that need to share the same data on a file system. So it's usually web servers in an auto scaling group. They sit behind a load balancer, and when an application needs to serve some bit of data, it could be a user upload, it could be just some static content. It's very common for web servers to mount an EFS share and serve data directly out of them. So rather than having to sync or replicate data across many machines, you can basically have your web or your app servers be dumb and stateless. They have no data on them besides maybe their application, but they mount this EFS share Now they have access to a whole data set that they can return to, over some interface like HTTP in a website or something, loading images. That's the most common. It's pretty simple. Under the hood, it's all managed. You don't have to really do anything besides launch it. Amazon's managing it and maintaining it, keeping it online and available. It's very scalable. There's options when you deploy it to multiple availability zones. It can sit, across data centers, and it's kind of replicating under the hood. But it's you basically get the same file set but replicated across many data centers. So in the event of an AZ outage, your data set is still existing and being served through these other availability zones. So it does take advantage of that global footprint that AWS has, and it's very durable and very available. I did talk briefly about some of the use cases. I talked about web serving. That's the most common one I've seen. Web serving and content management, like WordPress is a really popular deployment that customers run on AWS for like marketing and like information. Like most businesses are running some sort of CMS system, and WordPress has been a popular choice. But pick and choose your flavor. Most CMSs are running on some flavor of Linux, and most CMSs will have things like user uploads and static content. And this is really where we see EFS come into play a lot. But of course, there are other use cases, things around big data, where you got many machines processing data and needing some sort of file system storage or state. EFS comes into play in those sort of workloads. Media, workflow processing, you got many transcoding compute machines coming online to interact with videos or other sort of media, and doing like content analysis or transcoding or just running jobs on the data set. But it's essentially how you scale out one data set with many different machines. As depicted here. All right, so when you launch an EFS instance, you basically get a reachable DNS endpoint. It's got dynamically generated IDs here, but the end results, once you launch an EFS instance and you launch it into certain select availability zones, it becomes available to mount on target machines. And so like I was discussing, like I mentioned with the user data, how you can automate this, it's kind of it's a one-line command at this point. You just mount an NFS4 instance, you provide the DNS endpoint and the file system path where you want it to be mounted on your machine. And from there, all you got to do is read and write data to that file system like you would natively, and it's just happening under the hood on that EFS share. So this has been pretty Linux focused so far. And I don't want to leave out our Windows workloads because there's a lot of those. The equivalent in the Windows world for shared file systems, being kind of like based around SMB protocol, Windows file sharing, is a service called FSX for Windows. And very similar to EFS, it's shared file system storage, but for Windows. It's the native SMB protocol. It integrates with Active Directory, and whether that's you're running your own Active Directory on premises or on EC2 or with a managed AWS service called Directory Service, it integrates natively with any and all of them, and it supports all of the traditional enterprise deployments. It's an NTFS file system, and it supports DFS replication and namespaces. Right? So you can run many FSX shares and replicate data, between on-premises or even workloads on EC2 through FSX. And same exact premise. You can mount this FSX share on many Windows machines, and kind of this same thing as this little depiction here. All right. So now we're going to cover kind of the third storage option there, which is object storage. And really, this is essentially Amazon S3. So this is one of the flagship products, and I feel like almost every organization in the world is leveraging S3 to some capacity, right? So when you're sharing pictures on Slack, you know, a lot of times if you're going out to eat and you're scanning a QR code to look at some restaurant's menu, you may notice that most of the time the URLs say s3.amazonaws.com, and that's because it's, you know, probably the world's biggest and most reliable and durable object storage system. Very highly available, very easy to set up buckets and upload data or objects onto them, and very easy to share data globally. And it's even more powerful when you couple it with Amazon CDN service CloudFront. You basically get that object storage. It's very cheap on top of very cheap CDN capabilities, and you can have global deployment of some data that you want to serve within minutes. And then on top of that, there's a lot of powerful things that AWS has been doing on top of their simple storage service over the years. That makes it very powerful, very flexible. You know, even down to like different lifecycle rules and policies for managing the data sets that sit in those buckets. And there's a ton of different options with the buckets. It used to be that you had just a bucket. You'd launch the bucket, you'd be able to upload objects into it. And the offering has grown, right? So customers with needs around cold storage or long-term archival storage, there was Glacier, you know, and then over the years, they've just been kind of expanding and finding different blends of these different options for customers with all sorts of different needs. So intelligent tiering is something that we recommend to customers who they've been operating on AWS for some time. They've got data in buckets. But there's not a good breakdown of, you know, what the data access patterns actually look like. So intelligent tiering is essentially able to assess and evaluate data in an S3 bucket and determine which storage option is best for a particular object. And if you allow it to, it'll actually change and modify the configs of those objects to take advantage of the different storage classes. So this helps customers save a lot of money, especially if you got a lot of data in S3. And then across the board there is just the different options, right? So infrequent access, you got standard and one zone. And this is, again, going back to those storage characteristics. You pick and choose the right option for your workload, you know, based upon the performance, the availability, the durability, the reliability, the price. You know, but depending on your needs, there's an option for you. And if there's something that, you know, there's some option that doesn't fit exactly what you're looking for, you know, AWS is very customer focused and customer obsessed. And usually all it takes is talking to your account manager or some sort of contact at AWS. You can open a ticket. And AWS is always looking for feedback to see, you know, what else they can do to improve their platform to delight their customers. Again, back to S3, there's a lot of powerful components under the hood. It's a bit more than just upload an object and then serve it out. There's a whole lot of capabilities around the administration and the management of that data. All right, so you can tag objects to be able to group, you know, into different logical groupings. You can set up different prefixes, which helps with policies and management, right? So you can have different prefixes for different teams or people or customers of your own, and be able to define policies around access controls based upon the prefixes. There's versioning, right? So if you upload a file and then you subsequently make a change to that file locally, you can upload it again. And if versioning is enabled, rather than just overwrite and you lose the original version, you basically retain all the versions. This, of course, comes with a cost. It's additional storage that you're paying for. But for most customers, this is worth the cost. You know, usually versioning is on almost across the board. So you can monitor all the data within S3, right? So with the various monitoring components of AWS, you can integrate S3 with them. You can set up alarms. You can set up different log parsing patterns to determine different storage events and notification things. You can replicate buckets from one region to another if you are concerned about regional availability. You can replicate your S3 data to other buckets, in distinct, geographically distinct parts of the world to get that full coverage in the event of some regional outage. You can do things like intelligent tiering, which I had mentioned already, to automatically assess which is the proper storage pattern for a given object. And one of the most often used things is called S3 lifecycle. And this is essentially how administrators can define lifecycle periods for the data that sits in S3. It is pretty cheap to just throw some data onto S3, but usually you don't want the data to just grow infinitely, and customers leverage lifecycle rules to control the data sets and basically to be able to automatically move data into other things like Glacier to be able to take advantage of the archival storage and low cost. And then you can basically set up a chain of, after 90 days, move an object to Glacier, and then after 365 days, delete it. So you can have kind of a granular life cycle policy around the data that sits in the bucket. And then kind of in that modify column on the right there, there's a lot of other integrations that AWS provides around S3, right? So you can have automatic invocations of other services, like Lambda, for example, when an object is uploaded in the bucket. One of the most common use cases is image resizing. If you ever look into this, you'll see documentation for image resizing a lot. But the premise is basically when a user uploads a file in my application, I upload it to S3, and customers will have an integration with a Lambda function, which basically does image resizing. It's got the image magic or whatever image manipulation libraries that the language uses. You've coded it up, or you've downloaded an open source tool that does it, and you can get automatic thumbnail generation, or different ways to change the underlying picture. You can watermark it or timestamp it or do lots of interesting and unique things there. But the point is that it's flexible and you can trigger automation based upon events or things happening in that bucket. It's also very secure, right? So it's very integrated with IAM. And so in addition to being able to manage IAM users, roles, and policies and whatnot around who or what's allowed to access S3 buckets and their data, the other side of this is you can set up S3 bucket policies. So you can, from the bucket level, also define permissions around who or what is allowed to do what with the data set in that bucket. So you can do things like enforce encryption so that anything that gets uploaded automatically gets encrypted. You can turn on audit logging. You can leverage other AWS services like CloudTrail to be able to get basically an audit log of who pushed data, who read data, who interacted with my bucket. You get all of the data, all the data operations in the data plane logged, and you can review and alert and assess this object, the integrity of the objects, and to see who's looked at the data. There's another service called Macy out there, which is basically able to parse or crawl an S3 bucket and determine what sensitive data is in that bucket. And so a lot of customers are implementing Macy where they've got sensitive data in S3. They use Macy to discover it, and that's typically integrated with other tools to automatically remediate and notify administrators. So the last little section to talk about here is around how customers can integrate their existing on-premises storage systems into AWS. There's a lot of options. So the most common one that I see is storage gateway, kind of top right in the orange circle there. I think that's why it's orange. It's kind of the call out. So storage gateway is a lot of customers' first foray into getting their storage workloads on AWS. And the premise is essentially you can launch a virtual appliance, it's called a storage gateway appliance. You launch it in your on-premises environment, in your Hyper-V or your VMware deployment, and it's basically it sets up a file system which you can mount, or even you just raw block storage that you can also mount. And what this is doing is interfacing natively with an S3 bucket. So if you've got a storage solution on premises and you've got a file share or something of that nature, you can set up a storage gateway appliance locally, and it will cache and basically push all that data into S3. And from the operator perspective, you can go then see that data in S3 and you can interact with it up on Amazon, right? So you can launch an EC2 instance and launch a storage gateway up on AWS and be able to interact with the same data set. So it's typically how customers extend their data sets onto AWS and S3 in particular. There's some other options. Customers with much higher storage requirements, many terabytes or petabytes or even exabytes. They may be leveraging the there's three at the bottom that I'm referencing right now. The first is AWS Snowball, Snowball Edge, and Snowmobile. Snowball is an appliance that AWS will ship to your office or to your data center, and you take this device, this ruggedized container, you put it onto your network, and you can basically upload objects or data from a file system or from a server or file share and move it into the Snowball. I think by default it's like an 80 terabyte ruggedized machine. You plug it in, get it on the network, copy data to it, and you ship it back to AWS. And they're actually going to export the data from the Snowball into an S3 bucket. So it's typically how customers will see data. If they're going through a migration, they'll leverage the Snowball or the Snowball Edge to capture data, file system, object, or even like machine images if you're using Snowball Edge to get the initial data set up into AWS, and from there they're doing differential syncs and keeping the data set refreshed as they're working through a migration. And if you are one of the customers where exabyte storage is in line for your organization, there is AWS Snowmobile. So rather than having to deal with a bunch of snowballs and dealing with all that, since it's only 80 terabytes or so, you can actually get a truck to pull up full of storage equipment, and you can migrate exabytes of data into AWS and S3 through Snowball. Let's see, I got a couple more callouts here. Data sync, pictured kind of bottom right, second from the right. Data sync is also an appliance that you can run locally, and this is essentially a file system integration. You point this at an SMB file share, I think even NFS file share. And then on the other side, you can point it at an S3 bucket or an EFS share or an FSX share, and it's going to transfer file system data and then keep it in sync. And it goes both ways. If you can tell by the little arrows there. But this is another option that customers are using to get their initial data sets into the cloud, and onto some reliable storage service. Database migration service, bottom left, is typically how customers start migrating their database workloads over. So rather than a traditional like export database, upload the exported database file and then import it into a storage system, for customers who need more no downtime or close to zero downtime cutover of a workload they're trying to migrate, we'll leverage database migration service for them, or DMS. And this is basically a SQL name, whether it's Postgres or MySQL or SQL Server or even Oracle. DMS can be leveraged to basically set up replication from an on-premises or anywhere, any kind of relational database server that's running, and you can replicate the data into an AWS equivalent. You can bring that into RDS, or you can bring it into your own database running on EC2. And kind of last thing I'll call out here, which we see a lot, is direct connect. So this is more around networking connectivity. And so this is how customers are able to get dedicated fiber connectivity from their data center into AWS. It's not always an option for customers. You typically need to be at a data center that already has the connections built in. Otherwise, you'd have to work with your data center provider to work with AWS to set that up, or some other integration partner who specializes in direct connect. Alrighty, so that's essentially the content that I wanted to show for the storage solutions on AWS. So now let's get into a lab. In this. So again, if you have any questions, please share in the GoToWebinar, the panel on the right, or the question section, or feel free to just utilize the chat and talk to us. For this lab, same scenario as the last one. You're welcome to do this lab on your own little lab environment, or you're welcome to just kind of follow me as I go in the console here. Let me just quickly check to see if there's any questions or anything so far. All right, let's get into it. So we're gonna get started with S3. I got my lab on the left and my AWS console on the right. I'm gonna use the little search box at the top to just type S3. Let's see the options. I just want the S3 service. And so from here, there's a new account. There's nothing in here. We don't have any buckets. So I'm gonna create a bucket. So one kind of interesting about buckets is that the namespace, the bucket itself will be tied to a region, right? So you'll see this drop down. I get to pick my region that I want this bucket to reside in. And that's where the data in that bucket will be associated. It'll be in that region. But the namespace, or the name that you choose here, is global, and they have to be unique. And you're sharing these namespaces with everybody in the world. So if I try to make a bucket called test, I guarantee you this bucket's not available because somebody already made a bucket named test. So the names do have to be unique. So I'm gonna call this bucket Lance ID. Today's date is June 10, so 2021 06/10. I'm gonna slap a little date stamp on there with my name so I know this is unique, or at least the chances of this thing existing already are very rare. So you'll notice some other options here. It looks a little different from the lab. I'm in the newer console, which AWS just released. It's essentially the same thing. The defaults here are going to prevent any sort of public access and public capability for the data here. It's all going to be private data until I choose to expose it publicly, which I don't plan to. Let me skim through the options here and see what else it wants me to set up. So we need a tag. let's tag is purpose. The tag key is purpose. The tag value is immersion day. What else? That's now in default. That's it. Hey, I'm gonna go outside the lab a little bit. I'm gonna turn on versioning. I like versioning to be on. And I'm good with the rest of the defaults. So I'm just gonna create this bucket. It should be pretty much instantly available. So now we've got a bucket. So now we're gonna add data to the bucket. So from here in the S3 console, you've got to click into the bucket with this little link here. And now I'm interacting with the bucket specifically rather than all my buckets. And here we actually want to upload a file. So I'm going to go back to my terminal here. And I want to go to my downloads, immersion day. And so I'm going to make a file called, oh wait, no, that's not the right one. There we go. Hello underscore world.txt. I'm going to say hello world. Let's see, the time is 10:23 a.m. PST. So I'm gonna just make a little text file. I'm gonna put in some example data. I'm purposely putting in the time because I set up versioning on my bucket, and I want to showcase, how the versioning will work to you all. But I'm gonna save this little txt file, and I'm gonna click the upload button back in my AWS console. And I'm gonna add files. I'm gonna navigate to my downloads where I have this. Can't change my options. I'm gonna upload my little txt file here. Hello underscore world.txt. It's a little plain text. I have the option to set different storage classes like we talked about in that slide deck. I'm just gonna do standard. I have the option to set permissions. I could make this publicly accessible so I could share a link and post it out to the world. I'm just gonna leave it private for now. Actually, let me double check that that's what the lab says to do. Oh, the new version, just later on. All good. So I'm just going to take over. I am actually going to make this my little text file. I'm going to make it publicly accessible. I'll share the link and you can open it, or I'll just do it here. You do have to check the box. There's a lot of there has been a lot of security incidents in the past around customers accidentally exposing data they should not have or they didn't mean to. So there's you'll notice a lot of these built-in things that really make sure you understand that you're uploading some data to S3 and that this is going to be exposed to the world. And so AWS just really wants to make sure that they highlight the risks for you and that as an operator you're aware of the ramifications of doing so. This is a simple text file. There's really nothing of importance in it. So I'm just going to do most of the defaults, but I am going to make this a readable file. And I'm going to upload it. Oh, upload failed. Oh, I got access denied. That's right. I need to disable that permission. So AWS saved me from myself. because when we created the bucket, this default was in place to block all public access. The ACL prevented me from uploading a publicly accessible object. So I'm going to remove those training wheels and get rid of that ACL and try it again. I'm going to add my TXT file. Will be publicly accessible. I approve the risk and upload. Green bar, uploaded successfully. And there will be a link below directly to it. Shows you it takes you to the object itself in the console, so you see the metadata. But in addition, if you're looking at this metadata, you'll see an actual URL to the object. So you click it, and my browser will load my plain text file. Hello world, 10:23 a.m. PST. So let's do some other stuff. I'm partial to using a terminal because I'm a bit of a nerd. So I'm actually going to go back to my event engine dashboard, click AWS console, and I'm going to paste these tokens in. And I'm just going to paste them into my shell session here, and make sure that I got my AWS command line tools. So now I'm basically going to do what I just did in the console, but I'm going to do it from a command line interface. I get a bit more power and control. It's a little bit faster for me. So I've got the AWS CLI installed. That's something you can install to your computer if you got a Mac and you've got Homebrew. You can do brew install AWS CLI. You can download the files if you're on Windows. There's different installation media, and even if you're in the AWS console, there's something called the Cloud Shell, and it's basically the command line interface, but in your browser. That'll take a second to spin up. So what I want to do now is I want to showcase to you the versioning that S3 is able to use. So I'm going to go back into my bucket. Let me resize these real quick. So kind of when we're in this little S3 dashboard, this will show us all our buckets. I'm gonna, in my terminal, create a new bucket, AWS S3 make bucket. We'll call this length ID temp. And if I refresh my console, you'll notice there's my new bucket, Lance ID temp. I'm going to use that here in a few minutes, but first I want to show you the versioning. So now that we've got several buckets populated, it's pretty common for customers to have tons of buckets in here. They'll manage them in the console, they'll manage them with command line tools, they'll manage them with CloudFormation or tools like Terraform. So in this console, I want to interact with our primary bucket where we've got our hello world text file. So I go into the bucket and I want to specifically showcase the versioning capabilities. So we've uploaded this file once. So if you'll notice this little button here, this little toggle, if you toggle it to say show versions, we'll see it's still the same thing, but there's a version ID here. Every time you upload an object and your bucket has versioning enabled, each version is going to get a unique ID, which you can reference that version of the object. So now what I'm going to do is I'm going to edit my hello world.txt file, and I'm going to change the time to 10:31. And instead of hello world, I'm going to say hello immersion day guests A bunch of line breaks and some more data because I'm not very original. So I'm going to save this. I'm going to exit. So now my file, my little txt file has been updated, and I'm going to use the command line to also upload that file. So I'm going to do AWS S3 copy hello world to my Lance immersion day 2021-06-10 at hello world.txt. Upload complete. So just for showcasing this, I'm going to untoggle show versions and I'm going to refresh. Not sure if you noticed, but the size of this text file has doubled. It was formerly like 26, about 30 bytes. Now it's telling me it's 67. So it looks like there's a new version. So if I click it and I look at the metadata and I load up this object URL again, I forgot to specify when I copied it that it's supposed to be publicly accessible. So let's read. I understand the effects. So I was supposed to specify some command line flags to specify that ACL to make sure I really wanted it to be publicly accessible. And so you'll notice the same exact URL as over here. You'll notice this one's different. It's the same URL, but this content's different. It's only because I didn't refresh. There it is. So, our hello world has changed, the time has changed, and we got a bunch of line breaks and some more data at the bottom. So that's showcasing how you can upload a file, you can make change to the file, and you can upload it again, and the reference or the link will still be the same, but the content will be different. But in the event you needed to roll back or view a different version, you have the option. When I toggle show versions, I'll see my initial version there, being 26 bytes, and I can click into it. And you'll notice this time I get a little bit different URL. It looks mostly the same, but there is a argument being appended to it there. And you can actually reference the version by just passing additional little query string with the version ID. So when I hit this, it'll load my previous version. But of course, the current version, you just remove all that stuff and can go back to it. Pretty sweet. What else does the lab cover? Moving. Right, so these, so I did create this second bucket, and to kind of showcase how you can interact with data in these buckets, I'm going to go ahead and I'm going to, I wonder if I can copy this version. I can't do it on a version. I can only do it on like the current copy. But I'm going to select this text file. I'm going to go to my actions drop down here, and I'm going to move. I'm going to move it to a different bucket. So I can type in the path. When working with buckets, you may have noticed that I'm using this little URI syntax here. This is how you have to reference buckets, not just by name. You can include this little S3 : / like you would a normal like HTTP or whatever URL. With this S3, I'm actually just going to browse. It's easier. It's going to present me with the buckets that I have. So I want to use my temp bucket. I'm going to choose that as the destination. It's going to fill in the text there for me. recommends I enable bucket versioning. Sure, why not? I do that. My object is slated to move. I click move and it's gone. So if I go back into my original bucket, you'll notice I no longer have any objects there. I still have some versions though. So even with versioning enabled, if I delete a file or I move it out of a bucket, it's no longer there. The versioned metadata still persists. It'll just show a delete marker. It won't appear when you're looking at the bucket, but as soon as you toggle the versions or you are doing a directory listing with versioning included, you will see those delete markers there. And if I click into my other bucket, the temp one, there it is. Since this is a new bucket and I just turned on versioning, when I moved that object over, you'll notice that there's no other versions. This is the first version in this bucket, and it's the most recent one, you know, the 67 bytes. And if I open it up, it's all the new data. So pretty cool. One last thing I want to show here is where is it? Pretty cool feature of S3 buckets is this thing called website hosting, static website hosting. So it's really just a feature that you can toggle on a bucket. I'm going to enable it. And what this essentially allows you to do is host static websites, just like HTML, CSS, JavaScript, directly out of a bucket. You know, you don't need a compute instance to run just to serve some simple content. You can just upload that to an S3 bucket and run it on. You know, you can serve it directly at S3, or you can even pair it with CloudFront and get a highly available, highly durable, simple website that's pretty much always online, and it's super cheap. I run a couple of these for personal websites, like my personal, like my old consulting page. You can hit it. You know, you'll notice my little web app here. Amazon CloudFront. I've got some jQuery on it for some JavaScript stuff I'm doing. Hosted out of S3 and AWS. There's my face. But this basically lets you just host. I can specify I want to run a index.html is my default page here. You can set up redirect rules. So if you wanted to point DNS at a bucket, you can have buckets redirect to other things. But I'm going to enable website hosting, and I should get a link here. Right, and so you'll notice in the URL, I get an actual like S3 website, useast1.amazonaws.com. When I load it, I get a 403 forbidden because I actually don't have an index.html, but I'm going to make one real quick. And I'm going to do like the most basic HTML boilerplate. I'm just going to say, what is up, immersion day crew? Close my body, close my HTML. And I'm going to upload it to S3. Once I do 10. Forgot those flags again. Okay, so just gotta update the permissions, make sure it's readable, and I refresh, and now I've got website hosting. Now all this thing really needs is more structure in the HTML, more content. You can load CSS, you can load JavaScript, you can get a pretty much fully interactive, immersive website on the cheap and very easy. A popular architecture pattern we've seen in the past couple of years, something called Jamstack is basically deploying static websites onto systems like this, S3 and CloudFront, some sort of CDN. And in the background, administrators will run some sort of backend API component, and just using JavaScript, be able to have front end just rendering and displaying content, reaching out to APIs in a back end, and affording very flexible and powerful websites, but just with a really basic deployment model. You basically just package up some HTML and sync it to a bucket. I want to show one more thing, which is really important for administrators. So S3, I mean, I mostly use S3 as a place to back up. For migrations, I'm using S3 as kind of a migration zone, like a temporary, like an intermediary place. And I'm going to showcase kind of how you can do that. So I'm going to make a new bucket for good measure, and I'm going to call it Lance ID. Let's call it sync. I'm going to put that in my clipboard. I'm going to refresh, and we'll see it there. So part of this command line tool that I'm using, this S3 component, you've seen me do copy, you've seen me do make bucket. I can delete buckets, but one of the components of this tool that I use the most called S3 sync, where you can basically, if you've ever done any work on a file system like on Linux or Windows, you've got things like rsync and robocopy. This is how administrators can sync the entirety of a file system or a directory with a bunch of files into an S3 bucket, and then keep it in sync. So I'm just going to copy my current directory into my new S3 bucket. And we'll see all of the objects here get uploaded. When I go into the bucket and not this one, there's all my files. And so by default, if I start adding new files like new file.txt and I sync it, and just run the same exact sync command again, there's my new file.txt. So when it comes to doing some sort of migration where we talked about things like Snowball and you're seeding data in S3, this is typically what's happening. Like in a real world scenario, customers are seeding data from their on-premises environments into an S3 bucket. They've got objects in a bucket, and once the Snowball is able to deliver files to the bucket, usually administrators are setting up some sort of recurring thing like cron tab on a Linux machine, or task scheduler on a Windows machine, and using AWS CLI and this exact command, usually with a script with some extra logic around it, to sync contents locally and keep it up to date. And it's just going to do a differential. If I do this again, there's nothing to sync, nothing's going to happen. And so by default, like if I delete something, I don't want my index.html anymore, I don't want my new file anymore, and I don't want my hello world anymore. I'm going to delete those things. Now I've got two objects in this bucket, my two key pairs. Except I deleted that one key pair, so I don't need that either. So now I got one, the built-in key pair I was given when I set up my lab environment. So now I'm going to run S3 sync, and you'll notice nothing happens, despite me deleting stuff. All those objects persist. But if you did wanted to truly mirror what changes happen locally, including deletions, you would include this extra command line flag, delete. Now it's going to delete all those things. And I refresh, and they're gone. So this, in conjunction with versioning, in conjunction with other AWS storage tools, is how most customers are getting their start with AWS and S3. It's probably the easiest thing to get started with, and just get data up into AWS and onto their reliable storage services. So with that, we're going to conclude the lab, and we're going to go into more into the topics around networking and security. So I'm going to be passing it over to Brian, my counterpart. So let me switch stuff over. Brian, you ready?
Yes, sir. One sec. Let me get my screen sorted out here. All right. So screen 1, 2, and 3. I don't know which is which according to.
I think it should like kind of gray the screen to show you. I see blank desktop.
Okay, this is the right one. Cool. All right. Of course, the screens are switched in presenter mode. That's great. How do I toggle my presenter mode? Actually, I got a better idea. Is that better?
Yeah, let's go.
Okay. Sorry, I had to do a little screen swappage. All right, so I got you guys, I think for the next hour or so, we're gonna cover some topics around security, and we're gonna talk about some networking, and then we're gonna jump into a little networking lab where we're gonna make some VPCs and play around with an instance. It's all gonna be pretty basic. So let's look back to security. So at AWS, we're going to talk about a little bit of just some of the security fundamentals. We're going to talk about IAM. We're going to talk about some of the AWS native security services and some of the best practices around those. So when you talk with AWS, you're going to hear a lot that at AWS, cloud security is job zero. It's a little bit of a misnomer that the cloud isn't secure. AWS provides a lot of options and tooling and services around very, very deep and granular control over security, tons of auditing and tracking around security. The security around AWS Cloud goes very, very deep. There's even AWS security certifications you can get that are specialty certifications, where if you really want to become a knowledgeable security administrator inside of the cloud, AWS has very specific training and certification tracks for that. The certification for the AWS security specialty is quite difficult, and it is a very kind of industry respected certification to get within the cloud. So if you want to look into that, you can Google that and check it out. So AWS has a ton of board accreditations and certifications. They list them all. These are all third-party vetted. You can download all the reports of all of the compliance reports that are available. You know, there's a lot of them. They cover almost all the major industries. You know, whether it's PCI, credit card processing, whether it's PHI and healthcare. So if you're curious if AWS covers any kind of like specific industry certification, the answer is usually yes. And it is changing and updating all the time. So you can kind of pull that information anytime off of AWS's website. And then if you need proof or the actual reports, AWS makes that available through a service called Artifact. So you can go to AWS Artifact and actually pull down the reports of how these organizations accredited AWS. So you can actually, prove it and see that how it happened. So one of the most important things and a really fundamental concept when you're talking about cloud security is the shared responsibility model. This is kind of at the core of how AWS wants its customers to approach security in the cloud. So we're going to kind of deep dive a little bit on this. So there's a kind of a combination of what in the cloud AWS takes responsibility for, and then what they expect the customer to take responsibility for. And when you combine those two, that's how you can kind of, achieve those accredited and secure environments within the cloud. AWS, this is kind of a general overview, but AWS takes responsibility for securing and maintaining their facilities. That breaks down to like the actual physical security of their data centers. We're going to go a little bit into that on the next slide. But it's kind of on the customer to secure and maintain the security of the actual resources that you deploy on top of, the AWS resources. So now where that line is kind of drawn, kind of ebbs and flows between the types of services you're consuming on AWS. Down here, it kind of calls out a few of them, like the scope is going to kind of change and move depending on if you're doing infrastructures, containers, or some of their managed services. Understanding who is responsible for what is critical to ensuring that. And a lot of that comes from reading documentation, reading security white papers, speaking and getting consulting from AWS partners or solution architects at AWS. Taking certifications within AWS will give you a lot of this training as well. And then just operating within the cloud. As you become a more experienced operator, a lot of these things are going to make more sense. So let's take a little bit of a deep dive on the shared responsibility model. So if you notice, there is a clear dotted line. Let's look at the bottom part. So AWS, they are responsible for things like compute, storage, database, networking, maintaining their global infrastructure, all their regions and availability zones, and including their edge locations. And anytime you see edge locations mentioned, that is referring to their cloud front, their CDN. Now, the customer, you are responsible for your applications, managing your IAM posture, which we're going to talk about IAM a little bit later, managing the configuration and patching of the operating systems that are running on, say, your EC2 instances. You are responsible for configuring your network firewall configurations. Now, they provide you with the firewall, and they provide you with some defaults out of the box for the firewall, but the actual configuration kind of falls on the customer's shoulders. You are also responsible for handling your data encryption. So AWS provides you with the data encryption services, but you have to actually implement that encryption policy. You're responsible if you want to do server-side data encryption, like say you want to not use AWS native key or encryption services and you want to kind of do it yourself, that is also on you. And then network traffic protection, that's kind of an open-ended one. That's basically saying it's on you to provide your, like if you're going to use a web application external firewall or any kind of networking security appliances on top of what AWS provides. That kind of protection kind of falls on you to set that configuration and set up those rules that will protect your infrastructure. So the big point to take away from all this is what AWS says on the right there, where you are responsible for what is in the cloud, and AWS is responsible for things that are of the cloud. So to meet your certifications and your accreditations, you're going to need to use AWS underlying services that are certified for that accreditation. So if you're going to say you want to launch a PCI compliant workload, AWS has over 290 services. Not all 290 of them are going to be covered under PCI compliance. There might be 14 services that are considered PCI compliant compatible. AWS does provide a service matrix that says what services are considered, green as far as or considered approved for each individual certification. So if you're going to build out a workload and you need to meet a certification, you're going to need to do some research on AWS's documentation around that. So, if you're using one of the services that are not, say, PCI compatible, you're not going to have a, PCI compatible workload. So, let's see. So we're gonna dive into a few of the nuances around what AWS considers themselves responsible for. Now, I mentioned earlier that AWS is obviously responsible for the physical security of their data centers. So AWS has a lot of data centers. When you look up a region, as we saw earlier with the global infrastructure slides, each region is made up of multiple availability zones. Now, an availability zone can be multiple data centers. So one availability zone doesn't mean one data center. It can mean anywhere from 3 to 7 data centers that make up an availability zone, depending on which one. Now, Amazon is 100% responsible for those data center facilities. They don't let anybody in them. In fact, I would say 99% of AWS employees have no idea where any of these data centers are. Amazon does not publish any of this information. They don't say where their data centers are. They don't give tours. They have a data center tour website. So if you want to see kind of the inner workings of an AWS data center that makes up one of the availability zones, they pretty much direct you to the website that kind of gives you a tour. So when they say nondescript facilities, that just means their data centers have no branding. It's not like that you go up to a data center, there's a sign that says, this is AWS Northern Virginia Availability Zone 1. Robust perimeter controls, obviously they're gonna have security around their buildings. Strictly controlled physical access, I think that's pretty obvious. People, they only let certain people inside these facilities. And then access is logged and reviewed. So AWS is they're very good at running data centers, and they're very good at securing them. Now, when we get down to some of the other layers within the cloud, we're talking about compute and we're talking about networking. AWS is 100% responsible for the hypervisor. So if you are a VMware admin, or you're a entity or organization that runs your own hypervisor, whether it's like Hyper-V or VMware, moving to the cloud means you do not have to do any more hypervisor management or orchestration or patching. AWS handles all that. So the underlying hypervisor management all falls on to the provider, to AWS. You get to only worry about the servers and compute instances that you're running on top of it. So AWS also handles the underlying infrastructure for the stateful firewall. I think when Lance was doing his demo around EC2, we mentioned something called security groups. So security groups we're going to talk about it a little bit in the networking slide as well, but security groups are managed by AWS. Security groups are a software firewall that every EC2 instance has to be a member of, and AWS manages that stateful software firewall. So also something that you as a customer don't have to worry about the orchestration or management of. So network security, AWS is responsible for some really baseline network security procedures. So they don't allow IP spoofing on any host. So you don't have to worry about any of that happening just out of the box. AWS doesn't allow packet sniffing, so you cannot set network cards into promiscuous modes to collect data on compute instances. That's all turned off at the hypervisor level, so that's something you don't even have to worry about. Unauthorized port scanning, so you can't launch an instance and then have it start going out and doing port scanning on other people's instances and other resources within AWS. That's a violation of terms of service. So if I go into AWS, I get into someone else's account, or I get into my own account or whatever, and I start launching port scanning attacks or port scans, that is a violation, which means AWS has full authority to terminate and kick me off the cloud. So the other big thing to note is all inbound ports are blocked by default. So AWS, when they say security is job zero, that means they take a explicit let's deny everything and only allow in what you want as a customer. So by default, their security, especially security groups, everything is turned off and blocked by default. You have to specifically open things up from the get-go. Configuration management, so we're talking about the actual configuration of your AWS resources, like your servers and databases. Things that happen on the back end, like say they're making an operating system update to something in the AMI catalog, or some kind of version update on like an RDS type, all that, they try to do that so that there is no impact to the customer, so you don't even really notice when updates or changes are happening to things that are provided by them. They obviously document all changes, so if something new happens in RDS or EC2 or ECS, one of these services, you can go and look at the versioning documentation to see what AWS changed. AWS will communicate to customers via the service dashboard. So AWS does provide a kind of a health status page called the service dashboard. You can go up and see what the health is of underlying AWS services at any time of the day. The personal health dashboard is going to show you the services that you use, whereas the AWS Service Health dashboard, I believe, is going to show all of the services that are available. Now, when AWS says it's built for continuous availability, that means all of their provided services are scalable, fault tolerant, meaning that if their services by default are going to be able to stretch across multiple availability zones. You don't have to tell them to do that. There's some services that you just flick a switch and it's going to do that by themselves. Not all of them do that, but some do. All availability zones are always on. So meaning that AWS doesn't have any outages or planned outages of a single availability zone. Meaning, I guess a lot of people, like when I come from my old data center world, we always kind of said we had an A data center and a B data center. And people tended to build workloads around always having the A data center as the primary and the B as the backup data center. AWS doesn't really think about that in their availability zones. All the availability zones are essentially equal. So you can pick which availability zone can kind of be your DR and then which would be your primary. In fact, AWS rotates resources around. So when you select, I want availability zone 1A, the underlying infrastructure might be different than what was 1A yesterday. So AWS, they tried to spread the compute and all the infrastructure, they try to spread it equally. So they kind of the underlying infrastructure kind of rotates around and people don't really know that. And it's not really explicit, but so there's no kind of like AZ that they say, okay, so if this particular region has 3 availability zones, put your DR in AZ3. AWS will never say that. They just say, you pick your AZ, it's totally up to you. Now, robust internet connectivity, each availability zones, they have redundant links, meaning if a primary link goes down between availability zones, there's lots of disaster recovery in place there. They design the network so that there can be multiple routes and multiple outages, but it won't affect service between availability zones. Disk management is an interesting one. A lot of customers ask questions about this. So one thing is like, oh, I'm using EBS or S3 or these storage services. What prevents other people from accessing our data? So AWS has a very, very intricate system for making sure that you only see your data. You can't go into other people's buckets. You can't go into other people's EBS volumes. You only see what's been allocated for your accounts. Now, when you grab an EBS volume or create an EBS volume or create a bucket, the underlying disk that is being allocated to you has been wiped. So anytime you delete or get rid of a resource, AWS has a whole bunch of layers of disk deletion and wiping and termination that happens before that disk is then reallocated to other people. All that's documented. You can read that anytime you want out on the web. Storage device decommission. So when AWS gets rid of disk, like say, they have old spinning disks that need to be upgraded or whatever, they go through a very documented NIST and DoD compatible, or I don't know, compatible, but approved way of destroying all of the physical media. So if you have a bunch of data on a volume and then you release that volume, or the underlying actual physical disk in the data center is being decommissioned, all that stuff is physically destroyed, and you can bet that your data isn't living on past or living on further than you expect. Now we're going to move on to a topic that is very deep. We could do a week just talking about identity and access management, otherwise known as IAM. So IAM is kind of the glue that holds all of the security and access and roles and policy together inside of AWS. Learning IAM is going to be key for managing security effectively in the cloud. So you're going to see certain terms with IAM used often. You're going to hear things like principals, authentication, authorization, privileges. You're also going to hear terms like roles and policy. All of these terms are very specific to AWS. So when you're learning IAM, what you learn in IAM is very much AWS centric. Learning IAM isn't going to allow you to kind of operate in the other cloud providers. This is all very AWS branded things. Now, when we talk about AWS and IAM, you're going to hear a couple of topics. We're going to break this out into kind of like how do we authenticate? Basically, how do we make sure the person coming in to the cloud and using and interacting with cloud resources are who they are? That kind of falls under authenticate. Then authorize. This bucket is essentially once you're authenticated and the cloud knows who you are and it has approved it, what are you authorized to do within the cloud? And a lot of that comes down to IAM policies. Now, the best way to kind of look at IAM policies is to actually look at some of it, and most of it is all JSON based. And it is all very structured. So you can make your own IAM policies, and in fact, it's very much encouraged. However, AWS does maintain a deep bench of pre-canned IAM policies. I think there's like over 830 IAM policies that are already written in JSON. So if you're not comfortable or familiar with like writing JSON, you can essentially just pick and choose the IAM policies that AWS is already providing, which is what a lot of people do. So audit. So everything that is done in IAM is audited and tracked using a service cloud called CloudTrail. So what is IAM principles? This is a tricky concept to understand, but I'm going to kind of actually jump out of the slide deck real quick, and I want to show. Let's see. So IAM is very, very, very well documented with AWS. And in fact, I would say it's good to spend more time than just hearing me talk about it and go through some of the IAM documentation on your own. But essentially, the workflow of how IAM works is initially you have a principal. So a principal can be multiple things. A principal can be a user or a group. It can be a role. Now, roles are something that are very important to understand as well. You can take a user that is federated, so through a Active Directory or some kind of federated access, they can be a principal, and then you can actually build a principal around an actual like application. Now, the authentication arm is when the principal comes in and the cloud says, "Are you who you say you are?" And I've authenticated that. And then it moves down to what's called authorization. And authorization is where the kind of the meat and potatoes of IAM comes into play. This is where the actual policies are. Now that the cloud knows who you are and has approved it, it's going to look at what you are now allowed to do. And a lot of that JSON, you're going to see, if you're looking at IAM a lot, you're going to see these same 4 things come up a lot. You're going to see effect, action, resource, and condition. So walking through the effect, action, resource, condition, I'm going to actually look at some example IAM policies. So if you go into the AWS IAM documentation, they give you a whole bunch of just simple example policies. I wouldn't say some of these are simple. Some of these are actually very specific, but let's look at a couple here. So in Dynamo, which is a NoSQL database, this is looking at a sample IAM policy. So the effect of this policy is you're either going to allow or deny. The action. Now, action is something in IAM where each service, so you got 290 services, each service is going to have a whole fleet of actions you can do that are specific to that service. Then you're going to say, these are the actions I can take. What are the resources? So sometimes in policies, you're going to see a star on the resource, and that just basically says any DynamoDB resource I can do these actions on. You can get very granular with the resource, so you can say, oh, I only want to allow you to hit a specific table within all of DynamoDB. So when you see things like, let's look back here at the documentation here. So when you look back here, effect is allow or deny, action is what specific service level commands and things can you do within that service. The resources, okay, which resources or which services can you hit? And then condition allows you to get even more specific, where condition you can say, I only want certain IPs to be able to do this, or I want only certain regions or certain times of day. It gives you even more like control using strings and some other stuff to even get more granular and fine tune your IAM policies. Now earlier, I'm sorry my dog's barking, but there's probably being food delivered right now. So looking back, when you go into the IAM, so this is the actual IAM console inside the cloud. I just wanted to show you that if you're kind of like freaking out and going, oh man, IAM policies look really complicated, you can go into the bench. I'll call it like, this is kind of the pantry for pre-made AWS IAM policies. And if you look, there's 828 of them currently, and you can kind of filter them down by service. So we talked about EC2 earlier and S3, so let's look at all the S3 policies. So essentially there's these pre-canned S3 policies that you can use. Like here's one that you just want to give someone quick access for everything in S3. You could grab this policy and apply it to a user or a group or a role. And so if you want to see the actual JSON for any of these policies, you can click the little JSON button. I already have it clicked here, but you can go into any of these policies and look at the JSON and see what the actual policy is and what it does. So that's just kind of an overview. I know JSON is, not everyone's cup of tea, but it's something that if you are going to kind of be an operator inside AWS, it's a good thing to at least be able to read and understand. Let me go back to the presentation. One sec. Where is my... So what can be an AWS principal? I think we kind of covered some of that. It can be your account owner, which is the root account. It can be users and groups and roles that you've made inside of IAM. And it can also, you can make a principal a temporary security credential. So if you want someone to come in for the cloud and just do something quickly, but you don't want their access to last a very long time, you can set temporary credentials, and that can be referred to as a principal. So let's move forward. Now, one thing to note when we're talking about the principals within IAM is users that you make inside of an OS. So say you have a Linux box or a Windows box and you make a local user to those operating systems, those cannot be referred to in IAM as a principal. IAM principals are all just kind of cloud native, whereas operating systems and application level users are not cloud native, and IAM doesn't really know what those are or that those exist. So they're kind of outside of the scope of IAM policy. So that's just something I want to note. AWS IAM has basically two different ways to come in and interact with the cloud once you're authorized. The AWS Management Console, which is the the web front end to AWS, and then there's also the API access. And when you saw Lance doing the S3 commands and all that stuff he was doing from his local laptop on the desktop, that was using this part, the API access. That was using the command line, and API programmatic access is how AWS likes to refer to it. So those are basically the two ways that you can use and leverage the cloud. So this is just a slide kind of summarizing some of the, this is really calling out, there's the account owner. So when you create an AWS account in your root and you have the billing set up and it's on your credit card, you are the account owner. You're kind of the all-seeing account across any AWS resources that are being put to that bill. And then down lower, you can then start delegating out all of your IAM users, groups, and policies. Now, the hierarchy of privileges, this kind of just shows that the top level of all IAM hierarchy is going to be the account owner, the root. Then the next level down is going to be the individual AWS IAM users and groups. I'm sorry, the users that you create, and then you can organize those users into groups. And then the lowest down on the totem pole is going to be temporary security credentials that you give out to people. So this just shows that your AWS root owner supersedes any IAM accounts that are created through that or under that account. So this just gives you a little bit of a view of kind of how people typically organize their IAM users and groups. You can organize by admins, developers, application level, or application-based groups. There's, let's see, different ways of letting people get into the console. You can give them, just typical username and passwords to get into AWS through the management console or the programmatic access. They support two different methods of there's two different ways to get into the your AWS account through programmatic access, and that's using X509 cert or using keys. I believe Lance, when he was doing his demo, he was using keys. You can enable multi-factor authentication, MFA, on any AWS IAM users. So in fact, that's encouraged. You can have them use physical or software MFA devices to use multi-factor. So AWS does support MFA, of course. So this is just a slide showing that local user databases, so say you spin up a MySQL or a Microsoft SQL database, you still have your local accounts to those databases, and they are really kind of outside IAM. You can use LDAP. So if you're an LDAP shop and you have a local LDAP directory inside of your on-prem environment, you can extend that out into the cloud. That is not a barrier for having users and groups. You can create federation through one-way trusts or even with Active Directory federation services. So this slide's a little confusing, to be perfectly honest, but it's just showing that you don't, even if you have IAM users and groups, you can still leverage your local user groups and databases and leverage your LDAP. So this is a slide kind of calling out to the Microsoft shops that might be listening or watching. So AWS has a kind of a choose your own adventure approach to using Active Directory and kind of how you can manage Active Directory. One second. Sorry about that. My daughter decided that she was going to unload dishwasher while I'm talking, so it's a little bit of background noise. My apologies. So the Microsoft Active Directory. So AWS has a service called Microsoft AD, Managed AD. I believe they call it MAD. It is a full-on, fully robust AWS cloud-based Active Directory that you can set up, and it is based on Windows Server. It supports trust relationships, so you can set up a managed AD inside of your AWS account and actually trust that back to your on-prem domains. So it can just be an extension of your existing Active Directory structure. They also have a simpler and much cheaper option called Simple AD that is actually Samba based. So if you don't need some of the more robust features like establishing trust relationships, you can just spin up a Simple AD, but you still want to do users, groups, and some of the, it's kind of a watered down version, and it runs on, it does run on Samba. So I think there's other restrictions, like I'm trying to remember this. Oh yeah, so if you're using the Active Directory Administrative Center, you can't use Simple AD. So if you're using kind of like the out-of-the-box Microsoft domain management tools, you have to use the MAD. If you're not kind of stuck to those and you just need a quick place to put users and groups for Microsoft workloads, you can spin up the Simple AD. Now, if you don't want to use the Managed AD and you don't want to use Simple AD, you just want everything to feed back to your on-prem Active Directory, you can use the AD connector, which you can deploy to your account, and it will essentially use Radius and sync all that user and group information out of your on-prem, where you don't have to have a domain controller or any kind of domain stuff in your AWS account. You can just use the connector. So there's different approaches for Microsoft compatible directory structures. So this is just kind of the outline. So we're going to talk a little bit about encryption. Encryption kind of falls under two camps inside the cloud. Encryption in transit. So this is going to be your SSL, your HTTPS, your secure shells into your Linux servers, and then it's going to be VPN access, through your on-prem environment and connecting into your AWS account. One second. Then there's encryption at rest. There's a lot of options there, but when you say object, so that's you can encrypt specific objects like within your S3 buckets, and that's kind of your S3 bucket encryption. Databases, you can encrypt your databases across all the AWS managed database services. You can encrypt your file systems, meaning your EBS volumes can be encrypted and your EFS volumes can be encrypted. I'm sorry, your file system would be your EFS, and then your disk encryption would be your EBS, your elastic block. So when we're looking at encryption at rest, the volume encryption kind of falls under what I was just talking about. You can encrypt your EBS volumes. You can encrypt your file systems. Now, another thing I want to call out down here is there's a lot of encryption services and third-party tools available in the marketplace. So like if you're a Trend Micro shop and you're using that to encrypt and manage your encryption on your on-prem environments, a lot of that stuff like Trend Micro is available in AWS Marketplace. So you can still use some of your third-party tooling to manage your encryption if you don't want to use the AWS native stuff. There's a lot of different paths for object encryption. So there's multiple ways to encrypt data in your buckets. One second here. Now, server-side encryption is allowing your servers, your compute instances to manage the encryption on your S3. Then you can also use your own provided keys. So if you don't want to let AWS generate keys for your S3 buckets, you can bring your own. And if you don't want to have the cloud manage any of your keys, you can do your own client-side encryption. So you can create all your own keys and do it yourself. Now, there's a lot of options on database encryption depending on which managed database service you use, but just know that you can essentially encrypt any database on any of the AWS managed services, whether it's RDS, whether it's Aurora, whether it's Dynamo. And there's lots of different options for doing that as well. I don't think we should go into all of them, but there's quite a few. AWS has we're going to talk about a couple, just the ancillary AWS services that are around security. One of them is called the AWS Certificate Manager. So I don't know if there's anybody here that does F5 or load balancing administration at their organizations or anything like that, but managing SSL certs at scale is quite complicated, because you have to manage new cert creation, you got to manage cert rotation, you got to manage expiring certs. Now, if you want, AWS does have a certificate manager service that can do all of that for you. AWS can kind of handle all the muck. It can handle key pair generation. It can do manage renewal and deployment. It can do domain validations on new certs. You can have these certs pushed out to your Elastic load balancers and CloudFront distributions. So if you kind of want to do an all-encompassing cert management, if you're going to have a lot of different websites and applications that need real SSL certs, you're going to want to take a good look at the AWS Certificate Manager. It's a pretty cool service. Now, say you have a whole bunch of keys and you want to manage a lot of different encryption keys that you want to make available to, applications or S3 buckets or compute instances. You're going to want to leverage the AWS KMS, as they call it, Key Management Service. It's where you can, store all your keys and then have a lot of your AWS components of your AWS workloads call back and access those keys programmatically. And there's a lot of different services that are integrated with KMS, and there's a lot of different AWS SDKs that can pull key information from KMS. It's a very key service with encryption keys, and it gives you centralized control. So all your keys can be stored in one place. You can set up automatic key rotation. KMS will hold the information for old keys for a certain amount of days, for decryption purposes, all these kinds of things. If you don't want AWS to create your keys, you can 100% bring your own keys to KMS. So you can generate all your own keys and then just store them in KMS, or you can use KMS to create keys for you and then also do all that rotation and whatnot. So it's a one-stop shop for your security keys. So the next topic I think we want to hit is the configuration management. There's a lot of different services that kind of make up, managing your configuration and auditing and logging. The two big ones we're going to start off with is CloudTrail. So AWS is not in my opinion, isn't the best at naming some of their services, because they have two services that sound very similar, which is CloudTrail and CloudWatch, although they do vastly different things. So the first one we'll talk about is CloudTrail. So CloudTrail is essentially going to log and track any API calls within the cloud. And almost everything is an API call. So when you start an instance, that's an API call. You stop an instance, that's an API call. You create a bucket, you list a bucket, you put an object in a bucket, you deleted an object. All of that is done through some kind of API call. And AWS CloudTrail keeps track of all that. So you got to think of AWS CloudTrail as like the closed circuit security TV that's always in your AWS account, seeing what everybody's doing, whether it's a person or an application or a something that was triggered automatically, like saying an auto scaling event or anything that involves some kind of API access, all can be fed into CloudTrail. So it gives you a very comprehensive view of what is actually going on in your account. It says who did it, when they did it, what resources were affected when the API call was made, and then where was it made from, like who did it. And then all of the CloudTrail information can be stored in S3. And then there's a lot of different ways to consume the data once it's collected. Very popular third-party services like Splunk, AlertLogic, Datadog, all these third-party companies can pull CloudTrail log data, and then there's a lot of different ways to aggregate it. You can read it in CloudTrail, or you can use some of those popular third-party services. Now CloudWatch is more performance-based, about what's the health status of your AWS environments. So what does it do? It can collect and track metrics, whether it's metrics around a database, whether it's metrics around an EC2 instance, whether it's metrics around a load balancer. CloudWatch can essentially collect all this data. It can store and monitor these logs, so you can create all sorts of dashboards. So you can say, I want to know how my web tier is doing on my production website. You can collect all the performance data from all the machines that make up your web front end, and then you can create a dashboard that just shows you a holistic view of that particular component of your infrastructure. Now, one important feature of CloudWatch is setting alarms. So you can say, hey, I want to know when my web front end is at 80% capacity. You can create an alarm that says, I want to know when the CPUs on these particular services are going above 80%. And then you can actually set up reactions and things that get triggered off of those alarms, and say, oh, well, when it gets 80%, I want to launch another instance and grow that or scale that group of web servers out horizontally. All that can be triggered through CloudWatch. Now, how can you use it? Out of the box, CloudWatch can monitor CPU, memory, disk, and network stats off the interfaces from your compute instances. So CloudWatch logs and CloudWatch events. So you can, so when a server is like terminated, that is kind of considered an event. So there's a lot of things that denote an event. You kind of have to read about that a little bit. It's a little complicated at first, but there's a thing called CloudWatch events. One of the use cases that is most common is using CloudWatch to automatically scale EC2 instance fleets. So when you have an application that can, kind of use the elasticity of the cloud and have a whole bunch of EC2 instances running behind a load balancer, you would essentially use CloudWatch to determine when that instance fleet should scale up or down based on the metrics that you set inside the CloudWatch app. View operational status. So that's essentially, you're going to create a whole bunch of operational dashboards for whatever teams. So if you want to have a network focused dashboard for your networking team, or do you want to have a database focused dashboard for your database team, you can create a lot of custom dashboards and present them in different ways to different people. Now, outside of CloudWatch and outside of CloudTrail, there's what's called VPC flow logs. And this is essentially a way that AWS collects all of the data around network traffic. So VPC flow logs is agentless, meaning you don't have to install a VPC flow log agent on any of your instances or on any of your, application load balancers or any kind of networking appliances or anything like that. It just kind of works. It looks at the ENI, so ENI stands for Elastic Network Interface, so all the traffic coming in and out of the instance's network card is tracked and logged. Then you can take the data from the VPC flow logs and present it to CloudWatch, and you can make dashboards based on that, and then you can also set up alarming. So all your network traffic, what IP requested what from where and when, all of that is tracked through VPC flow logs. Oh, so here's a animation showing some of the components within a sample log here. It's showing where was this activity happening, which AWS account, what was the source IP, so what was your customer's IP, where's the destination, what protocol was it talking over, and then what happened. Did the packet go through, was it rejected, was it accepted? So you can use this for triaging or looking at when problems happen or events or bad things. You can go back to your VPC flow log and see what happened. I want to talk a little bit about the WAF, which is the Web Application Firewall. AWS does have a comprehensive WAF that's available. It is something that you have to turn on and put in place inside of your AWS infrastructure. It's a competing web application firewall to a lot of third parties that also have web application firewalls available. AWS's WAF is cheaper, although it does require a lot more hands-on tuning and configuration. So when you spin up a WAF, I think it can go in front of, and there's only certain places you can place an AWS WAF. I believe it's in front of an API gateway, in front of a load balancer, and in front of a CloudFront distribution. So the WAF is something that it's as strong as you want to make it. Out of the box, it's pretty empty, but AWS has a whole bunch of published rule sets and kind of just default rule sets to block SQL injections or cross-site scripting, DDoS protection, stopping web crawlers from hitting your site and pulling down a whole bunch of information, bot traffic. So AWS has a lot of pre-canned rules that you can add to your WAF. They are not free for the most part. So when you set up an AWS WAF, they have a certain amount of rules that you can add that are free tier, but when you get into the more enterprise level stuff, you're going to be paying based on the rule sets that you add to the WAF. So when you're setting up a WAF, that's something you're going to want to consider, and maybe get some consulting from a company like us, like Mission, on how to best utilize your WAF. But once you kind of have it set up and working properly and filtering out all the traffic that you want it to filter, it can be very effective and it's scalable. And it is, like I said, even with running a bunch of rules, it's considerably cheaper than some of the other competitors' third-party WAFs. Amazon Inspector is another standalone service. It's a automated security assessment service. It's kind of to help improve your security and compliance that are deployed in AWS. So you essentially spin up Amazon Inspector, point it at groupings of your infrastructure, and it can run checks on your security posture, see if something is maybe a little too open, or maybe you have a public-facing bucket, or you don't have MFA enabled on an account or something like that. It'll look at your security posture automatically for you and then provide you with reports and alerting. One of the important things about Inspector is if you see, I think the third one down, it says integrates with CI/CD tools. That means that you can actually have Inspector monitor things that are coming through your CI/CD pipeline. So it can actually determine and find unsecure practices before it even gets deployed into your AWS environment. So it's a cool service. It has a bunch of rule packages that are out of the box. You can create your own rule packages as well. So something to look at if you want to kind of leverage very cloudy automated security. You can check out Inspector. Now, another service I want to touch on is the service catalog. I think a common question with customers are going, man, there's 290 services plus in the AWS console. I want to enable some of my developers to go start playing in the cloud, but I don't want them to just start spinning up everything. I don't want them to go and start spinning up, ground truth or some random service that we don't really need. If you want to kind of set up pre-canned infrastructure, we usually do that in AWS in the form of CloudFormation templates that are infrastructure as code that say, okay, you can deploy these types of instances and this type of database and within this size of a VPC. So you can essentially create what's called a product, and then you can group those products together in what's called a portfolio. And then that portfolio can be available to your end users. So if you notice on the left side of this diagram, you're going to have an administrator. So you're going to have like a cloud engineering team or a cloud operation team, or I don't know, some kind of cloud engineering group that says, okay, so what do we want our team members and our staff and our organization to be able to do? You can create those portfolios. Like say you go, oh, our developers want a LAMP stack. You could go and create a LAMP product, slap it into a LAMP portfolio, and then call it, hey, this is the new dev LAMP stack. And then your end users, they'll go into the service catalog within AWS, see that development LAMP stack, they hit a button, and it gets deployed through a CloudFormation template into an account, and that's all they can use. So they can't go in and start spinning up instances, they can't spin up databases, they can only go into the service catalog and deploy what you've essentially determined as approved infrastructure. So the service catalog, if you're going to scale and you really want to set up a sandbox and you don't want to let users go outside of the sandbox, you only want them to use what you've considered approved infrastructure, you can use the service catalog. This also comes in handy for making compliant workloads for things like PCI or SOC or HIPAA. So you can create these portfolios with products that are deemed compatible with the those accredited certifications, and then when people deploy out of those portfolios, that they're only using the services that are covered under, like say PCI or HIPAA or whatnot. So that's kind of a rundown on AWS Service Catalog. I'd say the biggest service and the most important one for managing configuration is the AWS config tool. So AWS config tool is essentially a tool that will record and look at any configurations inside of your AWS environments, and you can kind of group these together through different types of ways. So you can say, I want AWS config to monitor our production environment or this particular application or everything. And AWS config will do what's called recording. So it'll start looking at what are the current configurations, and anytime a configuration changes, it will note those changes. And you can use AWS config to kind of get a holistic view at all of your configurations throughout all different types of resources. So you can look at configurations on buckets, on databases, on servers. You can look at everything inside your AWS infrastructure through the lens of AWS config. You can use AWS for audit compliance, for looking at maybe security holes in your configurations. You can use it for change management, which is really important. I think going to AWS Cloud, a lot of companies that are really good at doing change management on-prem, when they go into the cloud, I think they have to kind of maybe leverage AWS config to utilize a new change management workflow. So once you're kind of using AWS config and you're recording all this data, you can create what's called an AWS config rule. So the config rule is what you as an organization can define as a good or approved configuration. And as AWS collects data through AWS config, it can compare what it's seeing to what your config rules say, and it can tell you if your infrastructure and your configuration around your infrastructure is like kind of a pass-fail scenario. So this is kind of a little animation showing you where AWS config rules kind of fit into the workflow. So you have your AWS config reading. If you notice, there's these boxes that say, like there's that orange box that says V1 and V2. So AWS config says, hey, you launched a resource with the V1 configuration, and it does not align with the rule because our rule says we only want approved infrastructure with the V2 configuration that maybe has like updated patching or updated components of the application. And when something is launched using the old configuration or something is still in your account with the old configuration, the rule that you set up can tell you about that. So it can go, oh, by the way, you just created this config rule, 60% of your resources are out of compliance. That's where that would come in. So now we've kind of covered some of the security best of services. Let's look at some of the additional best practices. So if you're kind of wondering like a holistic view of the health of your AWS account, you can use a service called Trusted Advisor. AWS Trusted Advisor looks at what's going on in your infrastructure around the framework of what's called the well-architected pillars. So if you're not familiar with well-architected, if you're not familiar with well-architected, I'm not going to worry about that right now, but it is something you should probably Google, because AWS says if you want to be an efficient operator in a cloud, you need to do well-architected policies and kind of build around being well-architected. And the Trusted Advisor takes a lot of those well-architected principles and applies them in a kind of a report card way. So it will look at, are you operating cost efficient? Are you operating performant? Is your infrastructure secure? Have you designed it for fault tolerance? Are you using some of the fault tolerant features inside of the services, or are you just running everything on, in 1AZ, for instance? So the Trusted Advisor dashboard, when you turn this on, it'll essentially scan your entire account infrastructure and give you kind of a report card and saying, you're not as efficient on cost. Maybe you're using instance sizes that are a little too big for how much they're actually being utilized. Maybe you could save money by resizing or taking advantage of something like savings plans or reserved instances. So Trusted Advisor is a very, very handy tool, and you just have to enable it inside your account. And as you build and grow, you'll get very friendly with Trusted Advisor. Amazon Macie, I think we already mentioned that in the S3 demo. I think Lance was talking about how Macie is an automated machine learning based service that can look inside of places where you're storing data like S3, and it can automatically find bad things. So you say you want to make sure that your application or your users are not storing credit card information into a bucket. You can have Macie kind of looking out and scanning your buckets and saying, oh, I found some credit card information or social security numbers or PHI information, or customer last names, some kind of identifying information about a user, or even passwords. Amazon Macie is essentially a service that can just look at all these things for you and then report back when things are happening. One of the other features of Macie is it can look for behavior. So if someone is suddenly moving data around in large volumes, which is outside of normal behavior, it can say, hey, somebody might be doing something they shouldn't be doing, and it can alert you. So it kind of looks at what some of the best practices are around data and around compliance, and will let you know when things are going awry. AWS has a very large marketplace of security tooling and security partners. So if you don't want to use the AWS native services around encryption or the WAF, or any number of like configuration management tools, there's a lot of stuff you can deploy and use right out of the marketplace. And the advantage of running these out of the marketplace is consolidated billing. So if you're currently using F5 or Cisco physical equipment and you want to run Cisco or F5 virtual equipment, you can go into the marketplace, deploy those things into your infrastructure, and then all of that will roll up into your AWS bill. You won't have to pay Cisco or F5 kind of on the side. Everything will just roll up into one bill. So you can dig around the marketplace, find vendors that you're currently working with, and see if their stuff's available in the marketplace. It probably is. Last thing, I think, well, there's a couple more things, but to kind of wrap this up, one thing we haven't talked yet about is hardening your compute infrastructure. So AWS has a lot of documentation and suggestions around how to make sure your instance has the proper patching, the proper configurations, and is kind of hardened, in other words, secure before it is launched into your infrastructure. Now, if you remember back when I said that AWS is kind of responsible for the underlying OS, that is sort of true in that they will provide the baseline operating system, but when you launch, say, a Linux or a Windows instance, those instances aren't always going to have the latest and greatest patches. So what this is showing is that you're going to launch an instance from the AMI catalog. It is on you as the customer to then configure and make sure that instance has the latest Yum updates or the latest Microsoft security patches. And then you are considering that instance hardened and ready for your use in your infrastructure. So now when you kind of combine everything I've been talking about, whether it's the physical security around the data centers, the network security, using the AWS native security services like the WAF and the security groups and NACLs and the in-transit encryption with like SSL certs. And then you look at your actual compute and system security with, hardened AMIs, patched AMIs that are secure, using AWS config, using IAM policy and roles, making sure your credentials and all your IAM users are using secure practices like MFA. And then when you add on your data security, your security around your disk volumes, your elastic file systems, and your S3, all of this is kind of like a holistic view of cloud security. It's very layered, it's very granular, and the best way to really be performant with AWS security is just get in there and start using it, and take the AWS training and the courses, and read the AWS documentation. So the last slide I want to touch on is AWS has a lot of documentation on security. They have white papers, they have lots of different blogs. They have really great YouTube videos, especially around like learning IAM and learning how to use AWS config essentially. So there's a treasure trove of documentation that you can refer to and learn about. This stuff it's been around a long time. AWS is over 13 years old. Their security is very, very tight, but also can be very complex. So I think the best thing to do is just read and watch videos and do labs and practice. And you can always utilize partners like us who can guide your hand along the way too as well. So I think with that, is there any questions? Did we get any questions? All right. I think we're going to move out of talking about security, and we're going to dive right into networking, which is actually one of my favorite things in AWS. I love AWS networking because it's really cool. Let me fire this up here. All right, so this is our last slide deck of the day, and then we're going to go into a little lab. I'm going to try and get through this one quick, but there's some really key fundamentals that we need to talk about when we talk about networking in the cloud. We're going to talk about these things, VPCs primarily, and then how you can, different patterns for actually connecting into the cloud, and then how traffic is kind of distributed around the cloud. So the basic fundamental building block of networking inside of AWS is called a VPC. It stands for Virtual Private Cloud. It is essentially this is really important, it's a logically isolated section of the AWS cloud where you can launch your AWS resources in a virtual network that you define. So you got to think of it as if you're a contractor and you're going to build a new housing, a new town, or you're building a new housing development. The first thing you need is a big tract of land. So the VPC is essentially that tract of land in the cloud. You can run one VPC, you can run multiple VPCs, but that VPC, once you've staked it out, is your kind of building block for all of your networking and your resources on top of it. So pretty much the starting block 101 is to create a VPC. Now, what kind of makes up a VPC is going to be, we'll talk about it here. So this is kind of a description of what a VPC really looks like. So the AWS cloud, that top level box, that would be really considered a region, or a specific region. So within that region, you can make your VPCs, and you're going to stick that VPC within an availability zone. Now, if you notice that there's some resources inside the green box and there's some resources outside the green box. So the resources inside the green box are AWS services that you can launch into your VPC. So when you create these resources, you're actually going to say which VPC these go into. And some of those would be your EC2 instances, like your VMs. RDS, which is a database service, you actually launch your RDS instances inside your VPC. Redshift is a data warehousing service. Your Lambdas, those will run inside of a VPC. But if you notice, there's some services outside the VPC, which is in this case it's Dynamo and S3. What those are globally available services that you don't specifically launch within your VPC, but your VPC can reach out and communicate to S3 or communicate to Dynamo, and it's going to use a thing called endpoints. But the point is, when you create a bucket that bucket is on a global service like S3, and it is not self-contained within your VPC. So just something to note that these aren't all the services. This is just a sampling just to kind of illustrate it, but there's a lot of different services that are VPC deployable, and then a lot of services that are kind of global that live outside your VPC. So just something to note. So let's look at some of the building blocks of VPCs. So when you create a VPC, you can add your subnets within different availability zones. So your VPC, you create it, you essentially establish a CIDR block. One thing to note is when you created your VPC and you've decided on your CIDR block, you are stuck to that. You cannot modify a VPC CIDR block after it's created. If you want to change it, like you didn't allocate enough IPs or you allocated too many IPs, you have to create a new VPC. You can't change that. Once you set up your VPC, it's kind of set in stone. So once you've created your VPC, you can start building out the underlying subnets, and then you can design those in a way that they can stretch and cover different availability zones. So each availability zone will contain one subnet. You can't have subnets that traverse multiple availability zones, but you can have multiple subnets within an availability zone, which is what this diagram is showing. Now those subnets are going to get a chunk of that CIDR block. So when you're designing your networks, you can bring up and down those subnets, and but you can't bring up and down the VPC. Once the VPC is set up, it's kind of there. And if you want to reconfigure it, you're going to have to destroy it and make a new one. So when you create a subnet within your VPCs, each subnet is going to have a unique route table. And each route table is where you're going to say where traffic can and can't go in and out of that subnet. So each subnet can have a unique route table. Route table is direct traffic out of the VPC towards, and this is just kind of a listing of different things that you can edit within the route table. So if you're new to AWS, you probably don't really understand what an internet gateway or a virtual private gateway or an endpoint is, but these are just some of the things when you're editing your route table, you can direct traffic. So things that are living in that subnet can go out and talk to other things. All of that is going to be managed through that particular subnet's route table. If you notice in this particular diagram, one of the subnets says a public subnet and one says a private subnet. I know in a lot of data center and on-prem environments, the public subnet would be kind of considered the DMZ, or that subnet that contains resources that need to talk out to the internet. Now in the cloud world, the only thing that makes a public subnet public is the attachment of an internet gateway. So if you see that thing at the top, we're going to talk about internet gateways a little more in depth, but essentially the internet gateway is a scalable service that you're going to attach to a subnet, and that's going to do that network translation from the external internet into the private subnet into the private IPs. So when you attach an internet gateway to a public or to any subnet, it becomes the public subnet. Now, how do you connect your internet to the gateway? I'm sorry, to your VPC to the internet. I was just talking about this. This is just a slide talking about the internet gateway. You can't tip an internet gateway over. It's horizontally scaled. So as you add more and more network traffic into a VPC and into a subnet, you don't have to worry about the internet gateway not keeping up or running out of CPU or memory. It's just one of those magic auto scaling services that AWS provides. Although when you attach a internet gateway to your VPC, it won't work right out of the box. You're going to have to define traffic to go out to that internet gateway, and you do that within the route table. So by default, the route tables pretty much don't have anything in it. And as you add things like an internet gateway to your subnets, you're going to need to update your route table. And here at Mission, if we're gonna launch or deploy this infrastructure for you, we're not gonna go and do this by hand. All this infrastructure, like creating subnets, creating route tables, creating internet gateways, creating VPCs, all of this can be codified and stored within CloudFormation templates or Terraform templates, and all that can be just deployed through code through CloudFormation stacks. And then that's really the best way to do it. But if you're new to the cloud and you just want to kind of experiment, you can definitely go in and do a lot of this by hand. But also just keep in mind that all of this can be used as infrastructure as code or deployed as infrastructure as code. Now, when you deploy instances into that public subnet, how does it actually talk and communicate to the internet? Well, it can use a thing called an elastic IP. If you're new to the cloud, you're going to hear this term a lot. It's called the elastic IP is essentially a virtual network interface. You're going to deploy and attach these network interfaces to compute instances in your subnets. And the instance is going to use that elastic interface as long as it's attached. What's cool about elastic interfaces is they can move and traverse instances. So say you bring an instance down, you can make that elastic interface automatically switch over to a new instance that gets launched. You are not charged for elastic interfaces by AWS unless you're not using them. So if you spin up 5 elastic IPs and you don't have them attached to any instances, AWS is going to charge you for that. But as long as you're using those elastic interfaces and you actually have them attached to instances, I do believe they are free. Now, what if you need to get your instances and your servers in the private subnet to be able to communicate out to the internet? Like say I launch some Linux servers in my private subnet and I need to do a yum update to get the latest patching. By default, those Linux instances are not going to be able to communicate out to the internet because of the security posture that AWS presents. It's always deny all. Doesn't actually allow that traffic out of the box. So when I'm designing and doing the networking on my new environment, you're going to launch what's called a NAT gateway inside of your public subnet. And then you're going to route traffic from those local, from the private subnet. You're going to edit the private subnet's route table to say all traffic that needs to go out to the internet goes to the NAT gateway in the public subnet. So this is just the easy way of making sure that you have servers that are not in the public subnet that can still go out to the internet to, grab patches, maybe grab software or resources, and whatnot. So this is a very common path. This is how AWS suggests you set this up. Now, one of the questions that come up a lot is if you own an AWS account and you want to spin up multiple VPCs, can other people create VPCs within your account? And that is what this is describing. I know this is a little bit, what this graphic is essentially showing is that I, as the owner, could create the VPCs, create the subnets, but I can allow other accounts through a thing called AWS Access Manager to deploy and utilize my VPCs for their resources. So there's this beta account and there's this gamma account. So if I have, say, a development team that's beta and a development team that's gamma, I can allow the beta account and the gamma accounts to go and deploy resources into my VPCs that I own under my account. But you have to allow them to do that, and you can do that using a thing called AWS RAM, Resource Access Manager. Now, there's a lot of things around VPC security. We've already talked about this a few times. This is AWS security groups. So security groups are stateful software firewalls that essentially protect compute instances. Every compute instance, whether it's a database instance or a server instance, when it gets turned on, is going to have a default security group. Now, you can create your own security groups and then add those instances into those security groups, or you can just use the default ones. But the point is, you have to have it as a member of a security group. You can't remove security groups from compute instances. The cloud will not allow you to do that. So you always have to have some kind of security group wrapped around an instance or a compute resource inside of your subnet. Now, this graphic is essentially showing that there's a security group for the web layer. There's a security group wrapping around the Elastic Load Balancer. Then there's another security group around the web layer, and then there's another security group around the DB tier. And all those are allowing different ports. So the security group around the load balancer is going to allow incoming HTTPS traffic, and then the security group around the web servers are then translating that traffic into port 80. So essentially in this diagram, SSL termination is happening on the load balancer layer. So the load balancer has the cert, it's allowing the secure traffic, but then behind the load balancer, it's just sending regular 80 traffic internally inside AWS. And then there's another security group down on the database layer that's allowing that 3306 MySQL connection to come in. So each security layer is allowing exactly the ports and the communication that it needs to, and then is denying everything else. And the important thing is over on the right, if you notice, the load balancer will not be able to reach down and talk to the database tier. So this gives you security, layered security. Now, NACLs are different than security groups. NACLs protect an entire subnet. So each subnet is going to have a NACL, a network access control list. Now, NACLs are stateless versus stateful. And by default, all NACLs allow all traffic. So NACLs is where you can get even more granular around your network security. So when you deny access on a NACL level, every single resource within that subnet is going to be denied that traffic. So it's kind of the overarching, all-encompassing security around an entire subnet. So all the resources within that subnet will be controlled by the NACL first. Now this is an optional level of security, meaning that by default the NACLs are open. So if you want to enable and start drilling down on security on the NACL, it's totally up to you, but by default, AWS kind of lets it fly. Supports allow and deny rules. So this is important because when you take AWS certification courses, one of the questions is they try to get you on is security groups are allow-based access because everything is implicitly denied by default. Now, the network access control lists are different because they can have deny rules. So when you're designing something and you want a deny, like an explicit, I want to block all traffic from this trouble host, you have to do it on the NACL level. You cannot do it on the security group level. Security groups are allows only. Network access controls are allows and denies. So that's just a fundamental kind of thing about AWS that does show up in a lot of their certification tests, just FYI. Now, how do you connect into your VPC once you've created it? Now, VPC endpoints is an important thing. I think earlier I showed you a diagram that said that there are certain components and things in the cloud that live outside of the VPC. And in this diagram, you're seeing, like, let's say S3. Like, so I have S3 buckets that my compute instances need to hit to either put data in or grab data out of. You need to set up what's called a VPC endpoint that's going to allow resources inside of that subnet to go and communicate to S3. Also, if you notice that you're going to need to set up an endpoint to talk to another global service like KMS, like the key management service. So essentially, if you have resources within your subnets that need to talk to global AWS services, you're going to need to set up an endpoint. IAM is not one of them. You don't need to set up a VPC endpoint to use IAM. But services like KMS and S3, yes, you will need to set up VPC endpoints. Okay, so how do we get VPCs to talk to other VPCs? Well, there's two ways. This is the old way, still available. People still use it, but it's called VPC peering. This is a non-transitive routing peering service that AWS provides. Essentially, you can peer, you can take VPC A and peer to VPC B, and then update your route tables saying which subnets from those two VPCs can communicate and cross over and talk to each other. And then that's how it works. So you got to set up your policy within the route tables, and you have to establish the VPC peering connection. Another important thing to note is it doesn't have any support for overlapping IPs. So if you have the same CIDR blocks associated to the two VPCs, it's not going to work over VPC peering. They need to be unique. Now, VPC peering in the older days of AWS got to be very complicated. So when you had a large organization that had many VPCs, maybe 50 to 100 or even thousands of VPCs, managing VPC peering requests, VPC peering network topography was very complicated. So AWS a few years ago launched a service called Transit Gateway. Transit Gateway is essentially the replacement for VPC peering. It's a hub and spoke model. So instead of making VPC A, B, and C kind of have to talk to each other on a peer-to-peer level, you can make all your VPCs hook into one single transit gateway and then handle all the route tables on the transit gateway level that handles all the communications in and out through a VPC. So it's a hub and spoke model. You only have to have one transit gateway to connect, tons of VPCs. I don't know what the limit is on how many VPCs you can connect to a transit gateway off the top of my head. I know there is a limit, but I don't remember what it is, but it's very, very high. Obviously, in the first bullet point, it says you can connect thousands of VPCs across accounts. One important thing to note here is it can connect your VPCs and on-premise through a single gateway. So you can use VPN connections and direct connect connections and hook right into a transit gateway, and then you can reach out and communicate to your VPCs through the transit gateway. So the Grand Transit Gateway is a very big Swiss Army knife networking tool to establish multiple VPCs, being able to communicate and share resources between each other. Now, I'm going to kind of breeze through this. There's essentially two different ways to connect your on-prem data center into AWS. The first is a VPN, a virtual private network. This is going to be probably this is what most people start with. This traverses the regular internet, so you're subject to network congestion and network connection. How good is your connection between your VPN endpoint to the cloud? So you're subjected to network outages or congestion. So it's not the most reliable connection, but it definitely does work. Many people use it. Now this is diagrams just showing that you're going to have a customer gateway that's going to live down in your data center. It's going to go over the internet and it's going to connect to essentially a virtual appliance called the virtual private gateway on the AWS cloud, and that's how it's going to give you your secure encrypted traffic between your data center or even in just your office. It doesn't have to be a data center. Really, any customer site can make a VPN connection into the cloud. Now, say your organization's outgrowing your VPN, or you want a dedicated high-speed connection to the cloud. So you don't want to go on the main highway. You want your own private HOV lane. You're going to use what's called AWS Direct Connect. Now, AWS Direct Connect is something that's provided through third-party companies. So you're actually going to have to use a non-Amazon AWS company to set up and maintain and manage your Direct Connect. But if you notice in this diagram, there's a thing called Direct Connect location. So depending on where your organization is in the country, you're going to decide on a AWS Direct Connect vendor that is close to you, and they're going to have a location somewhere that you're going to connect to their location, and then the third-party vendor is then going to have a high-speed pipe that is hooked into the AWS backbone. So you're not using the Direct Connect to connect from you to the AWS cloud. You're going to connect from you to the Direct Connect provider, and then the Direct Connect provider has the superhighway into the AWS backbone. This is going to be a much more performant setup. It's going to be more reliable, but it is also going to be considerably more expensive. So if you notice at the bottom, there's 90 plus Direct Connect locations across the globe. This slide was created in 2019. I'm sure that number is much higher now. You can set up redundant circuits with AWS Direct Connect, meaning you can have more than one Direct Connect across multiple locations. So if one goes down or you need to have redundancy, you don't have to just have one Direct Connect. There's lots of different paths for having multiple Direct Connects. So if you're a really big organization, this is probably something you're gonna want to look at. How to access your VPCs through and your public services over your Direct Connect. This is just a pattern diagram showing that once your customer gateway is set up and you're connecting into your Direct Connect location, you're going to have that Direct Connect location hit multiple virtual private gateways across your VPCs, and then your VPCs can also communicate all to each other through transit gateway. So I kind of wish the transit gateway was in this diagram because it would look a little better, but this is just a common pattern. Okay, so I don't want to keep going too deep into Direct Connect because it is a very specific scenario that customers who really need a high speed, very high bandwidth connection into the cloud are going to utilize. So if you're going to go down this Direct Connect path, please reach out to us. At Mission, we've helped many of our customers set up and get Direct Connects going with vendors. Oh, sorry, this is the last diagram. This does have the direct connect diagram showing how it works with Transit Gateway. So the direct connect device is going to come into a gateway, and then the gateway is going to connect to the transit gateway, and then your transit gateway is going to, run traffic through all your VPCs. And this one's even showing it to be more complex, where it's using a multi-region approach. So you have maybe a region in the United States, and then say you have some infrastructure in another region, maybe you do business in Europe and you're using one of the European regions, you would only need to have that one direct connect gateway that could reach over to transit gateways in multiple regions. So you wouldn't need a direct connect that goes to London if you're using multiple regions. You can just leverage transit gateway. How is traffic distributed? Now, I think we could touch real quick on load balancing and ELB, which is a really in my opinion, one of the coolest services inside of AWS. So if you've done any F5 or load balance administration in the past, ELB is going to be very, very familiar to you. It is essentially the AWS cloud version of a load balancer. You can essentially use it to distribute traffic into compute fleets. There's a couple terms in here that are very specific to AWS that if you're new to AWS, these things are probably not going to jump out to you, but ELB is the load balancer. Then below that is something called an auto scaling group, an ASG. So when you hear a lot of things about the cloud, you're going to hear about how workloads can scale horizontally and vertically. So when we say a workload can scale vertically, that means we're going to use a EC2 instance that's going to have maybe bigger or better CPU and more memory. So we're going to make that instance bigger or smaller. That's kind of scaling vertically. And when you say horizontally, that just means adding more and more instances or EC2s into the the fleet. And how you manage that is through an auto scaling group. So when you design your application to be scalable horizontally, you're going to create auto scaling groups. There's different ways to do auto scaling groups, different patterns, but the ELB is what's going to send traffic and go into those auto scaling groups on behalf of your application. So your users are going to come in, they're going to hit the ELB. The ELB is going to know to send traffic to that auto scaling group, and then the auto scaling group is going to behave based on the parameters that you set around that auto scaling group. So there's essentially three types of Elastic load balancers inside of AWS. One's called an application load balancer, one's called a network load balancer, and then there's a third one that's not on this graph that's called a classic load balancer. So this is just some of the things that the application load balancer can do versus the network load balancer. I'm not going to go into the minutia around what the different types of load balancers do, but this kind of gives a really good breakdown that the application load balancer is way more smart. It can do a lot of things that the network load balancer can't do. However, the network load balancer is much faster. So if you kind of need a Ferrari, you're going to use the network load balancer. But if you want something that's more refined, and I'd say a majority of people use the application load balancer versus the network. So AWS does have its own DNS service called Route 53. Route 53 is a really robust service. If you don't want to use your own, if you're moving into the cloud and you want to bring some of your domains over, you're going to bring those into Route 53. It can do domain registration. It can do health checks. It can do DNS failover. It can do really cool things like geography-based routing. So inside of Route 53, you can say, hey, I have a load balancer in the United States, and I have a load balancer in London. And if users are coming in from London, send them to my London load balancer. If they're coming in from the US, send them to my US load balancer. So there's a lot of different patterns and available options within Route 53 to kind of slice and dice traffic down to your compute or your CloudFront or your load balancers. In the list on the left, some of those are called out. Like I said, there's geography-based routing, there's weighted, there's latency, so it'll go to the part of your network that's responding the quickest. So Route 53 has a lot of cool options, but just know that yes, AWS has its own comprehensive DNS service. So that's it for the networking portion. I kind of want to take a pause here, and we're going to finish off. There's a lab. I think we sent this out. There's a thing called the VPC. Hands-on lab. Should be a Word document. How are we doing on time? Let's do a time check here real quick. Okay, so looking at this, this is a pretty straightforward lab. What this is doing is we're essentially going to create a VPC using a VPC launch wizard. So let me go like this. I have the, let's see. I apologize, but I need to get back into my AWS account. Oops. Thought I had open in a tab, but I must have closed it. So just give me a second, please. Oh, I gotta send myself a one-time password to get back into this AWS environment. So apologize. Get this straightened out. Okay, we're back. Okay, so we've already seen the AWS console. I know Lance was doing a lot of things through the AWS console and through the API, through programmatic access. I'm going to do everything in here. So if we look at our lab is going to want us to go through the VPC wizard and create a new VPC with a public and private subnet. And then we're going to want to spin up an EC2 instance and see if we can ping and communicate to that instance from our computers. So the first thing we want to do is go into the console, and we're going to go to the VPC section. So all of your management of your VPCs and your networking is going to be done inside the VPC section of the console. There's a ton of stuff in here. It's very elaborate. This is where you're going to manage your VPCs, your subnets, your internet gateways, your NAT gateways, your endpoints, your network control list. Pretty much the kitchen sink that has to do with networking is all contained within this VPC console. It's got a lot in it. But when we go to the VPC dashboard, in this lab, you're going to be just running a wizard. So what's nice is you can go and create all these VPCs and subnets and routing by hand, or you can let the launch wizard do some of the heavy lifting for you with a really basic two-tier network. So we're going to click this button that says launch with public and private subnets. Before we do that, I think it wants us to create an elastic IP. Yeah, so when we're going to set up a NAT gateway, the NAT gateway is going to need an elastic IP to work. So the first thing actually before we go and make the VPCs is it wants us to make an elastic interface. So I'm going to go back. I'm just going to go back to the VPC dashboard. And we're going to go to elastic network interface. All right, Elastic IPs. I'm gonna make a new one. Oh, actually, I already made one because I was playing with this lab, but you're just gonna allocate a new Elastic IP. So you're gonna go into the Amazon's pool of IPv4 addresses. So they're gonna have a whole bunch of addresses that you can pull out of the kind of the bucket that they have available. So you're gonna create that. I already did it. I gave it a name, so when you edit, I don't think it's gonna have a name when you create it, but you can go in here and edit the name. I just called it my Elastic IP. Here's my IP address. Now, right now, I don't have this IP address associated to anything, which means I could start getting charged for it. So that's just when you leave Elastic IPs unallocated, that's when AWS hits you with a bill for that. So I think we'll go through the first part of just creating the VPC wizard, but I think all this is fairly straightforward. You're essentially going to launch the wizard. So we'll go in here. We're gonna launch the wizard. Now on the left here, we're gonna go with create a VPC with public and private subnets. So we're gonna hit select. Now the CIDR block is a big one. So it's gonna give you 65,000 IP addresses that you can slice up into multiple subnets within that. Now, just for lab purposes, we're gonna leave this. Now the public subnet and the private subnet, we're gonna have to slice up those IP addresses into different CIDR blocks. Now, if you're not a networking person, you don't really understand this, that's perfectly okay. Just essentially know that we're setting up a big tract of land, and then we're making smaller subdivisions using that IP space, and we're making that unique to those particular subnets. So there's a private subnet and a public subnet. So we're gonna call our VPC, I'm gonna say test version day, let's just say test VPC. So no preference means let AWS pick an availability zone, but I'm just gonna stick it in AZ1. We're gonna put the private also in the same availability zone. So these are gonna traverse one availability zone. Private, we're just gonna leave it called public and private. Now, here's the part where it's saying, hey, part of this stack requires a NAT gateway, but for a NAT gateway to work, you need an Elastic IP. So if you click the box, it's gonna auto-populate the Elastic IP that we already provisioned. So you click that. Now, the nice thing about AWS is it's like building with Legos. When we created the Elastic IP, it already knows that we did that, and we just kind of snap these together like building a Lego set. So we're gonna hit create VPC. Now this is gonna do a lot of things in this wizard for you that you could do by hand. It's gonna create the subnets, it's gonna create the route tables, it's gonna create the network, the NAT interface, and it's also going to create a internet gateway. So it's going to kind of set up a lot of it's going to kind of, do it for you as like a template. It does take a little while for all this infrastructure to spin up. So looking at the lab, I don't think I'm going to walk you guys through this entire lab. I think you can do this on your own. AWS said that these console counts are good for 72 hours. So if you want to come back and do this VPC or any of these labs later tonight or on your own time, you do have, over, the rest of today and tomorrow to play with these. But let's just walk through the lab guide real quick. So we've already launched the wizard. It's going to create this kind of infrastructure, what it looks like over here: a public subnet, a private subnet. We've already allocated the Elastic IP to the NAT gateway. It's going to tell you it's done. Now, one of the topics that this lab is going to talk through, and I found this really confusing when I first started playing with AWS and doing networking, was the difference between a main route table and a subnet route table. So in those diagrams earlier, we saw that each subnet has its own route table. Well, out of the box, when you set up networks, you have to associate a subnet to a route table. So you have to say this subnet is going to be managed by this route table. If you don't, all of the subnets are going to be managed by what's called a main route table. So the VPC, every VPC when it's created is going to have a default main route table, which is going to run all of the subnets until you start making and associating those subnets to their own route tables. So that's what this lab is going to try and walk you through. So it's going to show you that if you go into the VPC, you go into the main route table, you're going to see what's called an unassociated subnet. So an associate or a subnet that hasn't been associated to a different route table. There's going to be a thing called an explicit and an implicit subnet. So these are just kind of like kind of sort of complicated networking concepts, but once you start playing with this and going through the lab, I think it'll make more sense. So you're essentially going to associate that subnet to its own route table. Then you're going to create a, let's see, we'll also see, so by default, there's going to be already a route set up in the private subnet to the NAT gateway, which is going to allow all that traffic to go out through that NAT gateway. Now, one thing I want to talk about is when we go down, so this is a whole bunch of stuff where you're going to look at the routes. If we go down, you're going to get to a point in the lab where you're going to create an instance. So you're actually going to spin up a T2 Micro Linux VM, and you're going to launch it into your, let's see, which subnet are you putting it into? You're going to put it into the public. So you're going to launch this instance. You're going to put it into your public subnet, so in your quote DMZ environment. And then they're going to try to have you test access to that public instance. So that instance, when you launch it, you're going to learn that it's going to wait for that public IP address information to populate. Let's see. Oh, sorry. It's not going to get a default public IP because it's a new instance in a public subnet. In your own VPC, you're going to have to use an elastic IP to associate to that machine. So you're going to attach an elastic IP to that instance in your public subnet. That's going to allow you to hit it from your laptop. What's funny though is they're going to have you try to ping from your laptop that instance, and you're going to get a timeout because by default, the security groups, that software firewall that's always allocated to new instance types, is by default not going to allow a ping. So pings run over a protocol called ICMP, and by default, ICMP is not allowed on a security group because security groups don't allow anything. So this lab is going to have you launch an instance, attach a network interface to it, try to have you ping that interface, and it's not going to work. Then it's going to have you go in and edit the security group and add an ICMP rule. So they're going to actually have you add a firewall rule to the software firewall that kind of protects that EC2. And then you're going to ping it, and then it's going to work. So once you get to that point where you've launched the EC2 and you're able to ping it through its IP address out on the internet, that means you launched it in the you've launched it in the public subnet. The NAT, well, actually, you're not testing the NAT, but the elastic interface works, and you've opened up that port with the software firewall, and that's pretty much the whole lab. So I'm not going to go through that whole thing with you guys, but I think there's enough in here for you to go through it. It should only take you probably about maybe half hour to 45 minutes to check out the route tables, launch the instance, and get it pingable. So I think at this point I'm going to pass it over to Melissa, and we're going to kind of wrap up.
I think it's me actually, Brian.
Sorry, Scott. My apologies.
Yeah, no worries. So thanks
You're
for
definitely not Melissa. My fault.
thanks for taking us through that, Brian. I know, like, hopefully everybody here had a great workshop. Before we get into kind of today's offer, I wanted to launch a quick poll just to get a sense of where you all are at now that you've gone through this immersion day content. So I guess the poll is, are you interested in speaking with a Mission team member about your AWS migration or optimization after this workshop? And essentially, we're just trying to gauge interest so that we don't bother any of you folks. If you're not interested in our outreach, that's totally fine. But we will also be sending out some of the copy from today's Immersion Day webinar. So anyway, so you guys will have all of that. You'll get a copy of the presentation decks along with information on how to contact us. We'll just wait another second for those to roll in. Cool. All right. Thanks a lot for doing that. So I guess don't forget to fill out the CSAT survey, which will be sent to all of you. It's also in the chat, or will be in the chat if you want to go ahead and fill that out. We greatly appreciate any and all feedback that we can get from all of you so that we can help improve some of this Immersion Day content in the future. Again, just want to remind everybody, like, next steps here potentially is you can always schedule a call with Mission. So I think I mentioned this at the beginning of the day today, but always happy to get on the phone and talk through your specific use case and potentially ways we can help. Again, you know, no pressure, just an hour to chat with someone on our team. It would more than likely even be Lance and Brian if you liked hanging out with them today. So again, you know, information's on here. You can contact us through the website. You can contact us at our sales@missioncloud.com email address. There's also a phone number you can get in touch with us with. And I think that's pretty much it. So appreciate everybody's time today. I hope you have a great rest of your Thursday afternoon. Bye-bye.
Adios.